Far, far away, where the sun is just a bright star in an endless black velvet sky, there is a small world that holds the whispers of the solar system's birth. This is Pluto, a frozen heart of rock and ice, drifting at the edge of our cosmic neighborhood. It's not a planet anymore, you know, but a dwarf planet, a title that doesn't make it any less wonderful. It's a place of gentle mysteries, where time moves slowly and secrets are kept in the deep cold. Imagine standing on Pluto's surface. The sun is so distant that it gives only a dim, golden glow like a street lamp seen through a fog. The ground beneath your feet is a mixture of water ice, methane ice, and nitrogen ice, all frozen solid in the perpetual chill. There are mountains, not of rock, but of water ice, rising like silent sentinels into a dark sky. And across the plains, there are vast, smooth regions of frozen nitrogen, crackled with gentle lines like the surface of a frozen lake. One of these plains is called Sputnik Planitia, a huge, heart-shaped region of bright ice. It glows softly, even in that dim light, a pale blue-white like a pearl in the night. But Pluto is not a dead world. It has a thin atmosphere, a ghostly veil of nitrogen and methane, so faint that you wouldn't even feel it as a breeze. It drifts and swirls, creating a soft haze that catches the starlight. Sometimes, in the coldest parts of the day, that atmosphere freezes, falling as gentle snow onto the mountains, coating them in a frost of methane and nitrogen. It's a quiet, slow cycle, like the breathing of a sleeping giant. Deep inside Pluto, there might be a hidden ocean, a layer of liquid water kept warm by the slow decay of radioactive elements. This ocean would be dark and still, a secret sea beneath miles of ice. It's a possibility that makes scientists wonder if life could ever have found a foothold there, in that hidden, tranquil world. But for now, it's just a whisper, a theory that adds to the gentle mystery. And then there is Charon, Pluto's largest moon. It's so big that the two are often called a double dwarf planet system. They are locked together, always facing each other, like two dancers forever holding hands. From Pluto's surface, Charon hangs in the sky, a large grey orb marked with dark and light patches. It's a silent companion, a reminder that even in the farthest reaches of space, there is companionship. Pluto was discovered in 1930 by Clyde Tombaugh, a young astronomer who spent long nights comparing photographs of the sky. He found it as a tiny moving point of light, a faint speck that revealed a whole new world. For decades, it was just a blurry dot even in the best telescopes, a mystery we could only imagine. Then, in 2015, the New Horizons spacecraft flew by, sending back images that changed everything. We saw the heart-shaped plain, the icy mountains, the thin haze. We saw a world more complex and beautiful than we ever dreamed. Now Pluto continues its slow orbit, taking 248 Earth years to go around the Sun once. It travels a path that is tilted and elliptical, sometimes coming closer to the Sun than Neptune, but never colliding, always keeping its gentle distance. It's a quiet sentinel at the edge of our system, a keeper of frozen secrets from the dawn of time. As you drift towards sleep, think of Pluto, that small, peaceful world at the edge of the solar system. It's a place of stillness, of soft light, of ancient ice. It's a reminder that even in the vast, cold dark, there is beauty and wonder waiting to be discovered in a whisper, in a dream. Imagine, if you will, a quiet corner of the galaxy, far beyond the reach of our own sun's light. Here, in the deep velvet of space, two stars dance together, not around each other in a frantic rush, but in a slow, graceful waltz that lasts for billions of years. These are binary stars, and they share the sky in a way that is both intimate and serene. Close your eyes and picture it, a pair of suns, one perhaps a soft, golden yellow like a candle's flame, the other a gentle blue-white like a pale sapphire. They are bound together by the invisible threads of gravity, a cosmic partnership that began when a vast cloud of gas and dust, a nebula, slowly collapsed under its own weight. As the cloud spun inward, it grew denser and warmer, and within its heart, not one but two seeds of light began to glow. These twin suns do not compete for attention. Instead, they move in a quiet rhythm, orbiting a shared center of balance that lies somewhere between them. This point, called the barycenter, is like the fulcrum of a seesaw, and the two stars swing around it in a leisurely, eternal circle. Some binary pairs are so close that they nearly touch, exchanging streams of gas in a gentle, glowing embrace. Others are far apart, separated by distances greater than the whole of our solar system, and their dance is so slow that a single orbit might take 1,000 human lifetimes to complete. From a planet that might orbit one of these stars, the view would be a constant source of quiet wonder. Imagine a world where day does not come from a single sun, but from two. As the primary star rises in the east, casting a warm, honey-colored light, its companion might be seen as a brilliant second star, low in the sky, or perhaps it rises later, painting the landscape with a second, cooler glow. The shadows would be soft and dual, and the sky would never truly grow dark. At least not in the way we know. Even at midnight, if both suns were below the horizon, the light of the other star would linger like a twilight that never fades. The dance itself is a slow, careful thing. The stars do not rush. They circle each other with a steady, patient grace, like dancers in a ballroom who have all the time in the universe. Sometimes, if you watched for many years from that distant planet, you might see one star pass behind the other, creating a gentle eclipse that dims the sky for a few hours, a hushed moment when the world seems to hold its breath. Binary stars are not rare. In fact, most stars in the galaxy are born in pairs or even larger groups. Our own sun is something of a loner, a quiet, solitary star, but many of its neighbors, the ones we see as points of light in the night sky, are actually 2 or 3 stars dancing together. The bright star Sirius, for example, has a faint white dwarf companion that circles it in a slow orbit. From Earth, we see only a single point of light, but if we could travel there, we would see 2 suns sharing the same sky. There is a profound peace in this arrangement. The binary system is a closed world, a tiny universe unto itself. The 2 stars exchange their light and their gravity, and they influence each other's lives in gentle, subtle ways. Sometimes, one star grows old and swells into a red giant, spilling its outer layers onto its companion, a gift of gas and dust that can spark new life, new planets, new possibilities. The other star may absorb this material, growing brighter, or it may simply accept it, adding it to its own mass as the 2 continue their quiet dance. Eventually, after billions of years, the dance slows further. The stars may cool and fade into white dwarfs, or they might end their lives in a more dramatic fashion, but even then, the dance continues. The remnants of their existence, the dense cores and the clouds of gas they leave behind, remain bound together, orbiting the same invisible point in space. So as you drift towards sleep, think of those 2 suns far away in the gentle dark. They are not alone, they have each other, and they move together through the vast, silent ocean of space, sharing the sky in a quiet, eternal dance that asks for nothing but to continue. Let that image settle in your mind. 2 soft lights, circling one another with infinite patience, a reminder that even in the deepest night, there is companionship and calm. And as you let go of the day, imagine yourself floating among them, watching their slow, graceful turn, until sleep takes you gently into its own quiet embrace. Imagine a world where the sun never fully sets, where the sky is painted in shades of crimson and amber, not for a fleeting moment, but for an eternity. This is not a fantasy from a distant fairy tale, but a reality on certain exoplanets, worlds that orbit red dwarf stars, the most common stars in our galaxy. These are the quiet, unassuming stars, smaller and dimmer than our own sun, yet they hold the key to some of the most peculiar and beautiful landscapes in the universe. Red dwarfs, also known as M-dwarfs, are cool and long-lived, burning their fuel so slowly that they can shine for trillions of years. And because they are so faint, their habitable zones, the region where water can exist as a liquid, are incredibly close, often hugging the star in a tight, gentle embrace. A planet in this zone is tidally locked. One side always faces the star, bathed in perpetual daylight, while the other side is locked in endless night. But it is the terminator, the thin, twilight boundary between day and night, that captures the imagination. Here, the star hangs low on the horizon, never rising, never setting, frozen in a permanent sunset. The sky above this eternal twilight is a tapestry of deep purples and warm oranges, the star's reddish light filtering through the atmosphere. Perhaps the planet has a thick, hazy air, scattering the light into a soft gloaming that lasts forever. The ground beneath is cool, not cold, temperate enough for life, if life can adapt to the constant dusk. Imagine standing on such a world. The star is a large, dim disk, perhaps 4 or 5 times the size of our moon as seen from Earth, glowing like a dying ember. The stars beyond are bright and steady, for there is no true night to wash them out. The landscape is alien. Maybe it's a world of gentle hills, covered in a dark, hardy vegetation that has evolved to photosynthesize in the red light. Plants might be black or deep purple, soaking up the scarce photons. The air is still, with no day-night cycle to drive winds. The silence is profound, broken only by the rustle of something moving in the half-light. These eternal sunsets are not just beautiful, they are also a scientific wonder. Because red dwarfs are so active, they can flare, sending bursts of radiation across the terminator. But life, if it exists, might have evolved protective shells or bioluminescence, glowing softly in the perpetual twilight. The terminator zone itself is a strip of constant mild weather, neither scorching hot nor freezing cold, a Goldilocks region where conditions might be just right. We have found many such worlds already. Proxima Centauri b, the closest exoplanet to Earth, orbits a red dwarf and is likely tidally locked. TRAPPIST-1 hosts 7 Earth-sized worlds, some in the habitable zone, all with eternal sunsets. These are not lonely places, they are worlds of quiet wonder. As you drift off to sleep, imagine yourself there, on the edge of light and shadow, watching a star that never moves, a sunset that never ends. The universe is full of such gentle mysteries waiting to be discovered, and you, in your dreams, can visit them anytime. So close your eyes, and let the eternal sunset of a red dwarf world be the last image in your mind. A calm, serene glow as the star hangs low and the galaxy turns slowly above. Good night. Imagine, if you will, if you're so far away that the light from its sun takes over an hour to reach it, a place where the very fabric of the solar system is spun into a delicate, silent dance. This is the world of Saturn, and its rings are not solid nor still. They are a slow, drifting ocean of 1 billion ice crystals, each one a tiny, frozen world unto itself. If you could float beside Saturn, you would not see a sudden flash of light or hear a crashing roar. Instead, you would witness a gentle, almost imperceptible motion. The rings, stretching over 280,000 kilometers from end to end, are thinner than a sheet of paper in comparison, mere meters deep in places. And within this vast, paper-thin plane, everything moves in a stately, unhurried waltz. The smallest grains, finer than dust from a frosty morning, drift as if sleepwalking through the void. Larger chunks, the size of boulders or hills, tumble slowly, their edges worn smooth by eons of silent collisions. It is a slow motion because the forces here are gentle. There is no atmosphere to rush past, no wind to howl, only the soft, persistent pull of gravity from Saturn, from its many moons, and from the particles themselves. This gravity creates delicate ripples, like the surface of a pond after a single raindrop has fallen. These ripples, called density waves, travel through the rings at a pace that is almost meditative. They are not waves of water, but waves of ice, a slow-motion shiver that takes hours or even days to pass a single point. If you were to watch for a very long time, you would see the rings breathe, expanding slightly, then contracting, as the moons tug at them from their distant orbits. The crystals themselves are mostly water ice, but they are not all alike. Some are as clear as glass, catching the faint sunlight and scattering it into 1 million tiny rainbows. Others are darker, coated in a thin layer of dust from meteorites that have wandered into the ring plane over billions of years. In the darkness of space, they glow with a soft, reflected light, a pale, creamy yellow like the inside of a seashell. They do not sparkle or glitter harshly. Instead, they emit a steady, gentle luminescence, as if they are holding onto the sun's warmth and releasing it slowly, like a memory. And the motion is not just within the rings. The entire ring system itself is slowly shifting. Over centuries, the rings are gradually raining down onto Saturn, a ghostly drizzle of ice particles pulled by the planet's gravity. This process is so slow that it is almost impossible to see in a human lifetime, but it is happening. The rings are not eternal. They are a fleeting, beautiful moment in the life of the solar system, a temporary crown of ice that will, in another 100 million years or so, fade into the atmosphere of the gas giant below. But for now, they are here, drifting in their slow, silent ballet. Sometimes a tiny moon, no more than a few kilometers wide, orbits within the rings, clearing a path through the ice. This creates a gap, a dark lane in the glittering ice field. These little shepherds, called moonlets, push the ice aside with a patience that is almost unimaginable. They do not rush. They simply drift, and the ice slowly, obediently moves out of their way. It is a dance of immense scale and infinite gentleness. As you watch, you might notice that the rings have a subtle banding, like the rings of a tree, but made of ice and shadow. These bands are caused by the resonance of Saturn's moons, their gravitational pull creating regions where the particles are pushed closer together or pulled farther apart. It is a symphony of forces, playing out over millions of years, with no audience but the silent stars. The colors are soft, pale gold, faint cream, and the barest hint of rosy pink, where the light catches the ice at just the right angle. There are no harsh lines, no sudden changes, just a gradual, soothing gradient, like a watercolor painting left to dry in the sun. And all the while, the ice crystals continue their endless journey. They circle Saturn once every 10 to 14 hours, depending on their distance from the planet. But they do not race. They glide, as if time itself has slowed down here, near the great ringed world. If you could close your eyes and imagine this scene, you would feel a deep sense of peace. The universe, in its vastness, is not always about explosions and violence. Sometimes it is about the quiet drift of a billion tiny mirrors, each one reflecting the light of a distant star, moving together in a harmony that has lasted since before humanity looked up at the sky. And so, as you rest, you can think of Saturn's rings, not as a distant, frozen spectacle, but as a slow, gentle river of ice flowing silently through the dark. A billion crystals, each one a tiny, frozen world, drifting in a slow motion that is the heartbeat of the cosmos itself. And in that slow, steady drift, there is a stillness that can cradle you, like a lullaby from the edge of time. Close your eyes and imagine a quiet night far from city lights. The sky above is a deep, velvety black, scattered with countless stars, some bright, some faint, like tiny candles in a vast cathedral. But what you can't see, what no human eye can ever see, is that the stars are not still. They are moving, drifting, floating through space in a slow, majestic dance. And far beyond them, at the edge of the known universe, there is a gentle pull, a cosmic river drawing everything toward it. This is the Great Attractor, a name that sounds grand, even a little frightening, but it's not a monster. It's more like a quiet, massive heart beating in the dark, sending out a gravitational whisper that reaches across hundreds of millions of light years. And we are part of its flow. Let's start with a small story. For a long time, astronomers knew that galaxies were not standing still. They were all moving away from each other as the universe itself expands. But when they measured the motion of our own Milky Way, they noticed something odd. Our galaxy, together with its neighbors in the local group, was moving at about 600 kilometers per second relative to the cosmic microwave background, the faint afterglow of the Big Bang. That's fast, about 1.3 million miles per hour. And yet, when they calculated the pull from all the visible galaxies around us, it wasn't enough to explain that speed. Something else was pulling us, something huge, something hidden. In the 1970s and 1980s, astronomers began to map the universe in greater detail. They discovered a region of space, about 200 million light-years away, in the direction of the constellation Centaurus, where a dense concentration of galaxies was gathering. But this wasn't just any cluster. It was a massive, diffuse concentration of mass, perhaps a supercluster, that was acting like a gravitational anchor. They called it the Great Attractor. And it wasn't just pulling us, it was pulling thousands of galaxies, all of them flowing toward it like leaves in a gentle stream. Now picture this: the Great Attractor is not a single object, but a vast, diffuse region of space filled with clusters of galaxies, many of them hidden behind the plane of our own Milky Way. The dust and gas in our galaxy's disk blocks our view, so we can't see it directly. It's like a hidden treasure, a secret heart of the local universe. But we know it's there because of the way galaxies move. They are all drifting, slowly and peacefully, toward this point, as if obeying a silent command. This flow is called the Laniakea supercluster, a Hawaiian word meaning immeasurable heaven. Our Milky Way is just one of about 100,000 galaxies in this supercluster, all of them moving together, drawn by the Great Attractor. It's like a river with the Great Attractor at its center. But the river is very slow because space is vast. Even at hundreds of kilometers per second, it takes billions of years for a galaxy to travel from one side of the river to the other. So the pull is gentle, almost imperceptible, like the tide of an ocean that you can't feel, but that you know is there. And here's a beautiful thought. We are not being pulled towards some terrible dark void. The Great Attractor is simply a region where gravity has gathered a little more mass. It's a natural part of the cosmic web, the structure of the universe. It's not a black hole, not a monster, but a gentle meeting point, a place where galaxies are slowly, over eons, drawn together. They will never actually collide violently because the universe is expanding and the attractor itself is also moving. Instead, they will continue to flow, like a river that never ends, always approaching, never arriving. Astronomers have since discovered that the Great Attractor is itself part of a larger structure, the Shapley supercluster, which lies even farther away. So the pull is not just from one point, but from a whole region of space, a gentle, widespread gravity. It's as if the universe is breathing, and in that breath, we are carried along. So when you look up at the night sky, remember that you are not just a spectator. You are a passenger on a planet orbiting a star, in a galaxy that is drifting through a cosmic river, pulled by an invisible, gentle hand. The Great Attractor is not a destination, but a direction, a journey that has been going on since the beginning of time. And it's a peaceful journey, a slow dance through the stars, a lullaby of gravity. Let that thought wrap around you now, like a soft blanket, as you drift off to sleep, knowing that the universe is holding you, guiding you, and you are safe, carried along in the quiet, endless flow of the cosmos. Close your eyes and imagine space floating far above the world, drifting through a sea of silent, velvet darkness. There is no sound, no wind, no hurry, only the soft glow of distant suns, scattered like grains of sand across an endless shore. But look closer now, because we are not merely floating among the stars. We are approaching something far more gentle, far more peaceful, a nebula. A nebula is not a thing of destruction, as some stories might suggest. It is a cradle, a nursery, a gathering of the softest, most delicate clouds in all the universe. These clouds are made of gas and dust, thinner than any mist you have ever known on Earth. They drift in slow, silent currents, lit from within by the faint, sleeping light of unborn stars. Imagine this, miles and miles of cosmic fog, tinted in shades of lavender, deep blue, and rose. The colors are not harsh, they blend like watercolors on a dark canvas. Here and there, the dust grows thicker, forming dark, feathery shapes like the wisps of a dream. And in the heart of these soft clouds, something wonderful is happening. Stars are being born. But there is no explosion, no violent flash. The birth of a star is a slow, patient process. It begins when a tiny pocket of gas, no larger than a speck of dust in our eyes, begins to feel the gentle pull of gravity. It draws in more gas, more dust, molecule by molecule, over millions of years. The gathering grows, becoming denser, warmer, and softer still. It is like a snowball rolling down a quiet hill, growing larger and larger, but happening so slowly that the universe itself seems to hold its breath. As the cloud contracts, it begins to glow, first with a faint infrared warmth, then with a ruddy red light. This is a protostar, a baby star hidden within its cocoon of dust. It does not shine fiercely yet. It pulses gently, like a heartbeat in the darkness. And around it, the nebula continues to swirl, nurturing the young star with fresh gas, as if rocking it to sleep. Over eons, the protostar grows hotter and brighter. The dust around it begins to clear, revealing a soft, golden glow. And one day, if we could watch from a great distance, we would see a new star, calm and steady, shining for the first time. It will join the countless other stars that have been born in the same way, from the same patient, silent clouds. Now picture yourself lying beneath such a nebula. Above you, the sky is not black, but a deep, rich blue-purple like the last moments of twilight. The nebula stretches from horizon to horizon, a river of soft light and shadow. Tiny points of light, young stars, twinkle gently within it. Some are blue-white, some are pale gold, and some are almost pink. They do not rush. They do not flicker with alarm. They simply are, peaceful and eternal. The dust of the nebula is so fine that it feels like a blanket, even though you cannot touch it. It filters the starlight, making it soft and diffused. There is no harsh glare, no blinding flash. Only a gentle, dreamy radiance that washes over everything, as if the universe itself is tucking you in. And as you lie there, you might wonder, are we not made of the same stuff? The atoms in our bodies, the calcium in our bones, the iron in our blood, were once forged in the hearts of stars, born from clouds just like this one. We are, in a very real way, children of the nebula. To rest beneath it is to come home. So let your thoughts drift like the dust around you. Let your breath slow, like the gentle expansion of the cosmos. There is no need to hold on to anything. The stars will keep shining, the clouds will keep swirling, and you are safe, cradled in the soft, ancient arms of a nebula. Sleep now, under the quiet glow of a universe that is always creating, always dreaming, always at peace. Imagine a tiny spacecraft, no bigger than a small car, drifting through the vast, silent ocean of space. It has been sailing for more than 4 decades, a gentle traveler on a journey that began long ago, when computers were slow and the world was a different place. This is Voyager, and tonight, we will follow its quiet path beyond the bright light of our sun, into the soft, dark unknown. In the autumn of 1977, 2 spacecraft named Voyager 1 and Voyager 2 were launched from a place called Cape Canaveral, on a planet we call home. They were sent to visit the great giant planets of our solar system, Jupiter, Saturn, Uranus, Neptune, and then to keep going, ever outward, never to return. Their mission was a grand tour, a chance to see these distant worlds up close, to send back pictures and sounds from the edge of our neighborhood. And they did that beautifully. They showed us swirling storms on Jupiter, the delicate rings of Saturn, the pale blue of Uranus, and the deep blue of Neptune. They revealed moons with volcanoes and geysers, worlds that seemed like dreams. But then, after their main work was done, they kept flying. And now, decades later, both Voyagers are still out there, still moving, still speaking softly to us across billions of miles. They have crossed a boundary that no human-made object has ever crossed before, the edge of our sun's influence, the place where the solar wind gives way to the gentle breeze of interstellar space. This region is called the heliopause, a kind of bubble that surrounds our solar system, protecting it from the cosmic rays of the galaxy. Beyond it lies the vast, quiet ocean of stars, where the light of our sun is just a bright point among many. Voyager's journey beyond the sun is a slow, deliberate drift. There is no engine roar, no rush of wind, just the steady, silent motion of a spacecraft moving at about 17 kilometers per second, fast enough to cross the distance from New York to Los Angeles in a few minutes, yet slow enough that it will take tens of thousands of years to reach the next star. It is a lullaby of motion, a gentle falling through space, guided by the gravity of the Milky Way itself. As it travels, Voyager looks back sometimes. It took a famous picture called the pale blue dot, where Earth appears as a tiny speck of dust in a beam of sunlight. That image reminds us of how small and fragile our world is, floating in the immense dark. But Voyager also looks forward into the unknown. Its instruments still measure the particles and magnetic fields of interstellar space, sending back whispers of a place no one has ever been. The data is faint, the signal weak, but it arrives every day like a message from a distant friend. The spacecraft itself is a relic of an earlier time. It has a golden record on board, a phonograph record of sounds and images from Earth, a greeting to any intelligent life that might find it. There's music, laughter, whale songs, and greetings in many languages. It is a time capsule, a message in a bottle cast into the cosmic ocean. And as Voyager drifts further from the sun, that record remains unchanged, a piece of our world traveling through the stars. There is a calmness in this journey, no rush, no destination to reach by a certain date. Voyager will continue for billions of years, long after the sun has faded and the Earth has changed. It will become a silent monument to human curiosity, a symbol of our desire to explore beyond the known. The journey is not about arriving somewhere new. It is about the act of going, of moving outward, of letting go. So tonight, as you rest, think of Voyager. Picture it floating through the dark, its antenna pointed toward a distant Earth, its heart still beating with the faint pulse of a radioisotope thermoelectric generator. It is a quiet traveler, a lullaby of motion, a long, gentle song of exploration. And as you drift off to sleep, know that somewhere out there, beyond the sun, a tiny spacecraft is still sailing, still sending back its soft, steady signal, a reminder that we are all part of something vast and beautiful. Good night and sweet dreams among the stars. In the vast, breathless quiet of the cosmos, there drifts a kind of dancer, the spiral galaxy. It turns in a rhythm so slow and grand that a single rotation may take 200 million years. And yet, in that unhurried spin, an entire universe of life and light unfolds. Imagine yourself floating at the edge of such a galaxy, a place where the stars are sparse and the sky is a deep, violet black. Here you can see the whole structure before you, a great, glowing disk of stars, gas and dust, with arms that curl outward like the petals of a celestial flower. This is the life of a spiral, and it sings a song only the cosmos can hear. At its heart lies a dense, brilliant core, a city of ancient stars, each one a sun much older than our own. They crowd together, burning with a steady, golden light, bound by the gravity of a supermassive black hole that waits in the shadows. But the core is not a place of violence. It is a patient anchor, a silent conductor that keeps the entire galaxy in its graceful turn. From that center, the spiral arms begin to unwind. They are not solid things, but waves of density that sweep through the disk, gathering gas and dust into clouds that slowly collapse to form new stars. These arms are the nurseries of the galaxy, and in their gentle curves, life is born. Look closer, and you see the bright blue clusters of young stars, hot and eager, lighting up the dust lanes like gems on a velvet ribbon. The orange and red glow of older stars drifts between them, and dark streams of cool gas trace the spaces where future worlds will emerge. The whole scene is peaceful, despite the immense energies at work. There is no violence here, only the patient ticking of cosmic time. And what of the silence? Out here, sound cannot travel, but the galaxy hums in other ways, in the slow drift of dust across millions of years, in the whisper of gravity that pulls stars into their long arcs, in the faint light of a supernova that fades over centuries. It is a silence that does not disturb. It cradles the galaxy as it spins, a silent lullaby that has been playing since before our planet was born. The spiral is not alone. It is part of a larger family, a cluster of galaxies that drift together through the darkness. Sometimes, a neighbor floats close, and their arms reach toward one another like dancers in a slow waltz. The encounter may last 1 billion years, gentle as a sigh, and yet it can trigger a wave of new star formation that lights up the spiral's arms like a winter tree decorated with fireflies. Over time, the spiral will change. Its arms may loosen, its core may grow dim, and eventually it may transform into a simple glowing sphere of ancient stars, what astronomers call an elliptical galaxy, but that transformation takes eons beyond imagining. For now, the spiral turns. It turns in the endless darkness, a beautiful machine of light and time, spinning in perfect silence. As you drift back to sleep, you might picture yourself far above that glowing disk, watching the stars wheel slowly below. The galaxy does not need you to watch, but it is grateful for the company. It will continue its gentle spin, whether you are awake or dreaming. And in that thought, there is a deep comfort. The universe moves on, calm and steady, and you are part of its slow, beautiful dance. So let your breath fall into the rhythm of that distant rotation, slow, deep, and peaceful. The spiral galaxy has been turning for billions of years, and it will turn for billions more. There is no rush. There is only the quiet majesty of the cosmos and the soft light of a million worlds, each one a tiny note in the grand, silent music of existence. Imagine a place where time itself begins to slow, like a river reaching the edge of a great, still lake. A place where the universe's most powerful forces become a gentle, endless fountain. This is the world of black holes, not as monsters that devour everything, but as cosmic fountains, where the flow of time trickles to a near standstill. In the quiet darkness of space, far from the busy light of stars, a black hole rests. It is not a hole at all, but a region of incredible density, a pinch in the fabric of reality. Around it, a sphere of no return, the event horizon, marks the boundary where gravity becomes so strong that even light must pause. Here, time behaves differently. For someone watching from far away, a clock falling toward the black hole would seem to tick slower and slower, as if each second stretches into an eternity. But for the clock itself, time flows normally. It is the space around it that has become deep and slow, like honey in winter. This slowing of time is not a trick of the mind, but a real effect predicted by Einstein's theory of relativity. Near a black hole, gravity is so intense that it warps spacetime, creating a gentle slope that time must climb. The closer you get, the more time dilates, until at the event horizon, it appears to stop entirely, at least from the outside. This is the heart of the fountain, a place where time becomes a whisper, a slow dance of moments. Now picture this: matter from a nearby star or cloud of gas does not simply vanish. Instead, it spirals inward, forming a glowing disk of superheated material around the black hole. This accretion disk is like the basin of a fountain, where particles rub together, heating to millions of degrees, and release brilliant X-rays and light. But not all of this matter falls in. Some of it is caught in powerful magnetic fields and launched outward in narrow jets, streams of particles that shoot away at nearly the speed of light. These jets are the fountain's spray, reaching thousands of light years into space, seeding distant regions with energy and matter. The black hole thus becomes a cosmic fountain. It draws in, but also gives back. It slows time to a trickle at its heart, yet sends energetic streams far across the galaxy. These jets can trigger the birth of new stars, stirring up clouds of gas and dust. They can also shape entire galaxies, gently pushing and molding the cosmic landscape over millions of years. As you drift through this mental space, think of the black hole as a quiet, patient center. It does not rush. Its gravity is so immense that time itself bends to its will, creating a sanctuary of stillness. The universe around it may be fast and chaotic, but here, near the event horizon, time slows to a gentle pulse. And yet from this slow core, fountains of energy burst forth, connecting the black hole to the wider cosmos. It is a reminder that even the most extreme objects in the universe are not isolated. They are part of a grand cycle, a dance of matter and energy that spans billions of years. The black hole's jets carry the imprint of its slow time out into the fast-moving world, a subtle influence that spreads like ripples from a stone dropped in a pond. So when you look up at the night sky, consider the black holes that may be out there, hidden in the darkness. They are not voids, but fountains. They are places where time slows, where the universe pauses to reflect, and where the seeds of new stars are gently scattered. Their power is immense, yet their presence is calm, like the deep, slow breath of the cosmos itself. Let this image settle in your mind. A serene black hole, surrounded by a soft glow of gas and stars, its jets flowing outward like silent, luminous rivers. Time, near its edge, flows as slowly as a dream, and the fountain of creation continues forever and ever. Close your eyes and let your mind drift far beyond the troubles of this world, to a place where time moves at a pace so slow it stretches across billions of years. We are traveling now to the innermost planet of our solar system, a world of extremes and hidden mysteries, Mercury. Imagine a small, cratered world, grey and battered, hanging against the velvet blackness of space. Its surface is a stark landscape, scarred by ancient impacts, with long, winding cliffs that stretch for hundreds of miles. But beneath this quiet, rocky exterior, a powerful, silent story is unfolding. A story of cooling, of shrinking, of a heart that is slowly, patiently growing cold. You see, Mercury, like all rocky planets, was born in fire. In its earliest days, it was a molten ball of rock and metal, a churning inferno of liquid iron and nickel at its core. As it spun through the young solar system, it began to cool. And as it cooled, its interior began to contract. Think of an apple left in the sun, its skin wrinkling as the flesh dries within. But on Mercury, this process has taken eons, and the effect is written across its entire surface. The most dramatic evidence of this shrinking heart is found in the planet's great scarps. These are immense, cliff-like features, some rising more than a mile high and stretching for hundreds of miles. They are not created by volcanoes or earthquakes, as on Earth. They are wrinkles, the planet's crust buckling and thrusting upward as the interior shrinks. The largest of these is called the Great Valley, a trough that is over 600 miles long and 250 miles wide. A grand canyon carved not by water, but by the slow, steady cooling of a world. For decades, scientists have studied these features, using images from spacecraft like Mariner 10 and more recently NASA's Messenger mission. They have measured the height and length of these scarps, and they have calculated how much Mercury has shrunk over the past 4 billion years. The answer is surprising and humbling. The planet's radius has decreased by about 4.5 miles. That may not sound like much, but for a world only about 1/3 the size of Earth, it is a significant change. The entire planet has crumpled inward, like a balloon slowly losing air. But the story does not end there. New research suggests that Mercury is still cooling and still shrinking even now. Its core, once entirely molten, is now partially solid. As the liquid iron in the outer core solidifies, it releases heat, and the planet continues to contract. This means that new scarps may still be forming, and old ones may be growing taller. Mercury is not a dead world. It is a world slowly settling, its heart cooling, its surface gently rearranging itself over millions of years. And what of the future? In a few billion years, the Sun itself will begin to expand, and Mercury will be consumed. But until then, it will continue its quiet, patient dance of contraction. Its cliffs will rise a little higher, its craters will deepen, and its heart will grow a little colder. So as you drift towards sleep, think of that small, distant world hanging in the silent void. Think of its ancient cliffs, formed by the slow passage of time. Think of its cooling core, a patient fire fading into eternity. And know that even in the vast, quiet universe, change is always happening slowly, steadily, like a gentle heartbeat, growing softer and softer until it fades into the endless night. In the vast, silent expanse of the solar system, a tiny spacecraft named Voyager 1 was hurtling away from the Sun. It had already completed its grand tour of the outer planets, sending back the first clear images of Jupiter's swirling storms and Saturn's delicate rings. But on February 14, 1990, as it sped toward the edge of interstellar space, NASA gave it one final, poignant command: turn your cameras back toward home. And so, from a distance of about 4 billion miles away, Voyager 1 did something no human had ever done before. It looked back and took a photograph of Earth. That photograph has become known as the pale blue dot. When you first see it, it might seem unremarkable, just a faint speck of light suspended in a narrow band of scattered sunlight. You have to look carefully, because that tiny point, less than a single pixel in size, is our entire world. Every mountain, every ocean, every city, every person who has ever lived, all of that history and love and heartbreak, contained in a single, fragile fleck of blue. Carl Sagan, the astronomer who inspired this picture, later wrote about it in words that still echo through time. He said, "Look again at that dot. That's here, that's home, that's us. On it everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives." And he continued, "The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader. Every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam." Listen to those words again, softly. They remind us of something gentle yet profound, that our planet is a tiny oasis in the cold, dark vastness of space. There is no other place we know of that can harbor life, and this fragile blue dot cradles all that we cherish. As you drift into restful thoughts, picture Voyager 1 now, still sailing onward, carrying a golden record with sounds and images of Earth, a message in a bottle for any who might find it. The spacecraft is over 14 billion miles away, far beyond the planets, yet it still whispers to us across the cosmic ocean. Its cameras are off now, saving power for the long journey ahead. But that one last image, the pale blue dot, remains a timeless invitation to wonder. Think of the colors in that image, a thin, bright arc of sunlight lighting the pale blue of our home against the black velvet of space. It is a view of our world as a single pixel of life, a breathtakingly small stage for all our dramas and discoveries. In the quiet of this moment, let yourself feel how small we are and how precious, not with fear, but with awe. For even a mote of dust suspended in a sunbeam can hold an entire universe of love. Let that image settle in your mind as you breathe gently. Imagine the stars all around, the silent drift of the spacecraft, and the little blue dot receding into the distance. It is a picture of humility, of peace, and of the quiet miracle that we exist at all. And with that thought, you can let go of the day's worries, knowing that your own little dot of a world spins on, carrying you through the night. Far beyond the orbit of Mars, or beyond the asteroid belt, there drifts a world that is not a world at all, but a vast, swirling ocean of gas. Jupiter, the largest planet in our solar system, a giant of banded clouds and endless storms. And yet, for all its immense power, there is a place upon it where the fury falls silent, where the winds pause and the roar of the tempest becomes a whisper. This is the story of Jupiter's calm eye, a great and peaceful center within the storm. Imagine a planet so large that over 1,000 Earths could fit inside it. Its surface, if you could call it that, is not solid ground but a sea of hydrogen and helium, thousands of miles deep. Here the atmosphere is alive with motion, with bands of color that stretch from pole to pole, painted in shades of cream, rust, and soft blue. These bands are jet streams, rivers of gas that flow in opposite directions, some racing at hundreds of miles per hour. And within these bands, storms are born. Some small, some vast beyond imagining. But the most famous of all is the Great Red Spot, a hurricane-like storm larger than our entire planet, a crimson eye that has gazed upon the solar system for centuries. Yet the Great Red Spot is not the only calm center. Across Jupiter, there are many smaller eddies and whirls, each with its own quiet heart. The storms here are not like those on Earth. They do not have a surface to rage against. They are simply swirling patterns in the gas, like cream stirred into coffee, but on a scale that dwarfs our world. In the center of each storm, there is a place of relative stillness, where the winds drop and the chaos settles. This is the eye. For the Great Red Spot, that eye is a region of calm, a pocket of silence in the midst of a howling tempest that has lasted for hundreds of years. Scientists have studied this storm with spacecraft like Voyager, Galileo, and Juno, which orbits Jupiter even now. What they have found is both strange and beautiful. The eye of the Great Red Spot is not a void, but a place where the clouds thin, where the deeper atmosphere can be seen. It is a window into the planet's soul, a glimpse of the warm, moist air that rises from below to feed the storm. The winds around the eye scream at over 400 miles per hour, but inside, they are barely a breeze. It is a sanctuary of stillness in a world of motion. But why is it calm? On Earth, the eye of a hurricane is calm because the storm's rotation creates a low-pressure center, drawing air inward and upward. The same is true on Jupiter, but on a far grander scale. The storm is so vast that it generates its own weather, its own cycles of heat and motion. And in the center, the forces that drive the fury cancel out, leaving a peaceful core. It is as if the planet itself takes a deep breath, holds it for a moment, and then releases it again in a spiral of color. To imagine standing at the edge of that eye is to imagine a scene of surreal beauty. The clouds around you are a wall of churning purple and orange, lit by the distant sun. Above, the sky is a deep indigo, scattered with faint stars. Below, the eye stretches away like a great blue lake, a calm surface that seems to go on forever. There is no sound, for there is no air to carry it in the way we know. But if there were, it would be a low, constant hum, the breath of a giant sleeping. And yet even this calm is not eternal. The Great Red Spot is slowly shrinking, changing shape, its winds weakening. One day, perhaps millions of years from now, it will fade into the bands of Jupiter and the eye will close. But for now it remains a quiet reminder that even in the most violent places there can be peace. So as you drift towards sleep, think of Jupiter, of its whispering storms and its calm eye, a gentle giant in the dark, spinning slowly, endlessly through the night. Imagine a world without a sun, a planet drifting alone through the infinite dark, untethered to any star. These are orphan planets, sometimes called rogue planets or interstellar wanderers. They are not born from the collapse of a gas cloud like a star, nor do they orbit a distant sun like the planets we know. Instead, they are cast out, ejected from their home systems by the chaotic dance of gravity. Or perhaps they formed in the cold, lonely spaces between stars, never knowing the warmth of a parent star's light. In the vast emptiness of the galaxy, these rogue worlds drift silently, their surfaces forever shrouded in eternal night. Yet they are not entirely without warmth. Deep within their cores, leftover heat from their formation or from radioactive decay can keep their interiors molten, and some may even have subsurface oceans, kept liquid by the pressure and heat of the planet itself. Imagine an ocean of liquid water, hidden beneath miles of ice, gently lapping against a rocky seafloor, untouched by sunlight for billions of years. Could life exist there? Some scientists believe it's possible in the dim, pressurized abyss, where simple organisms might thrive on chemical energy, much like the strange life found in Earth's deep ocean vents. How do these orphan planets come to be? Most are thought to be born in young solar systems, where gravitational interactions between giant planets can fling smaller worlds out into the void. A planet may be kicked out by the immense pull of a larger neighbor or by the close passage of another star. Sometimes, a system's own star can destabilize its planets as it ages, sending them hurtling into the dark. And then there are the truly free-floating worlds, perhaps formed directly from the collapse of small gas clouds, too small to become stars, but large enough to become planets. These are like the forgotten children of the galaxy, wandering between the stars. The number of such worlds is staggering. Recent estimates suggest there could be billions of rogue planets in our Milky Way alone, perhaps outnumbering the stars themselves. They are incredibly hard to detect because they emit no light of their own. Astronomers find them through a technique called gravitational microlensing, where a rogue planet's gravity bends the light from a distant star, causing a brief, telltale brightening. Or they are spotted in infrared, as the faint heat from their still warm cores glows against the cold of space. Each discovery is a quiet triumph, a whisper from the dark. One of the most famous orphan planets is PSO J318522, discovered in 2013. It is only about 80 light-years away, and it is young, just 12 million years old. Its surface temperature is still a glowing 1,150 degrees Fahrenheit, a dull red in the infrared. It drifts alone, with no star to call its own, a testament to the violent and beautiful chaos of the cosmos. What would it be like to stand on such a world? There would be no sunrise or sunset, no day or night. The sky would be black, but not empty. A river of stars would stretch overhead, unchanging, eternal. The only light would come from distant galaxies and the faint glow of the Milky Way. The ground beneath your feet would be cold, but perhaps not frozen solid, depending on the planet's internal heat. A gentle wind might blow, but it would be thin and cold. The silence would be profound, broken only by the occasional low rumble from deep within the planet's crust. It would be a place of profound solitude, a world that has never known the warmth of a sun, yet still holds secrets in its dark heart. These orphan planets remind us that not all worlds are bound to stars. They are free, wandering the galaxy in eternal slow motion. They are the quiet wanderers, the unseen travelers, the hidden worlds that drift between the light. And as we learn more about them, we realize that the universe is not just a collection of stars and their planets, but also a vast, dark sea of solitary worlds, each with its own story, its own geology, its own potential for life. They are a humbling reminder of how much we have yet to discover, and how the most profound wonders often lie in the spaces we once thought were empty. Imagine, if you will, a time before stars, before galaxies, before even the first atoms had formed. The universe was a hot, dense, searing soup of particles and energy, a cosmic sea of light so bright that nothing could escape its glow. There were no shadows, no darkness, only an endless, blinding radiance. This was the universe at its birth, about 13.8 billion years ago, in an event we call the Big Bang. But the universe did not stay this way. It expanded, and as it expanded, it cooled. What was once a furious inferno became a little less fierce, a little more gentle, and about 380,000 years after the beginning, something remarkable happened. The temperature dropped enough for protons and electrons to combine, forming the first neutral atoms of hydrogen and helium. In that moment, the universe became transparent. The light that had been trapped, bouncing endlessly between charged particles, was suddenly free. It streamed outward in all directions, a great release of energy that filled the cosmos with a soft, uniform glow. This light, this ancient echo, is what we now call the cosmic microwave background, or CMB. It is the oldest light we can ever see, the very first light to shine across the universe. For billions of years, it has traveled through space, growing fainter and colder, its wavelength stretching as the universe continued to expand. Today, it bathes the entire sky in a faint, almost imperceptible microwave glow, a whisper of creation that still reaches us from every direction. If you could see with microwave eyes, the night sky would not be dark at all. It would be filled with a gentle, all-encompassing radiance, like the soft light of a distant sunrise. And if you looked very closely, you would notice tiny variations in this glow, subtle ripples and fluctuations, like the surface of a calm lake disturbed by the slightest breeze. These ripples are incredibly important. They are the seeds of everything we see today. Slightly denser patches of the early universe, where gravity pulled a little more strongly, eventually grew into the first stars, the first galaxies, and the vast cosmic structures that stretch across the heavens. For decades, scientists have studied the CMB with exquisite care, using satellites like COBE, WMAP, and Planck to map its faint patterns. They have measured its temperature, its polarization, its tiny variations, and from this ancient light, they have learned so much. It tells us the age of the universe, its composition, its shape. It confirms that the universe began in a hot, dense state, and that it has been expanding and cooling ever since. It is the most direct evidence we have for the Big Bang, a fossil of the dawn of time. Think of it this way: every time you look up at the night sky, you are seeing stars that are millions or billions of light years away, but the CMB is even more distant. It comes from a time before any star existed, from the very edge of the observable universe. It is the oldest story ever told, a message written in the language of light, whispering across the eons to tell us how it all began. So the next time you find yourself beneath a clear, dark sky, remember that the darkness you see is not empty. It is filled with the faintest of lights, a cosmic lullaby that has been singing since the beginning. And if you listen with your mind, if you let your imagination drift across the vastness of space and time, you can almost hear it. A gentle, steady hum, the echo of creation's first light, still shining, still traveling, still telling us the story of everything. As the first light of dawn touches the red planet, a soft, ethereal glow spreads across the ancient landscape of Mars. This is a world of quiet majesty, where the sun rises over dunes that have stood still for millions of years, and where the ghosts of rivers once carved their way through the rust-colored soil. Picture yourself standing on the edge of a vast, silent valley, the sky above you shifting from deep violet to a pale, peachy hue. The thin atmosphere holds just enough dust to scatter the sunlight, creating a gentle, hazy twilight that wraps around every rock and crater. The temperature is bitter cold, far below freezing, yet there is a strange warmth in the light, a golden pink shimmer that dances across the undulating sands. Beneath your feet, the ground is a mosaic of ancient textures. Here, the remains of what was once a great river delta stretch out like the fingers of a sleeping giant. These channels, now dry and dust-filled, tell a story of a time when water flowed freely on Mars, carving canyons and feeding lakes that shimmered under a thicker, more forgiving sky. Scientists call these regions the valley networks, and they are the silent witnesses to a world that was once alive with the sound of rushing water. To your left, the famous Jezero crater lies in shadow, its rim catching the first rays of the sun. This is a place where NASA's Perseverance rover now roams, collecting samples and searching for signs of ancient life. But in this quiet moment, the rover is still, its instruments humming softly as it waits for the sun to fully rise. The crater floor holds layers of sediment, laid down over eons, each layer a chapter in a book that tells of a wetter, warmer Mars. As the light grows stronger, the dunes come alive. They are not like the dunes of Earth, shaped by wind and water, but rather the work of centuries of thin Martian air. These are the Barcan dunes, crescent-shaped and graceful, their curves smoothed by time. They move slowly inch by inch, creeping across the landscape like a silent tide. The sand is rich in iron oxide, giving it that familiar rusty red, but in the dawn light, it glows with an almost coppery sheen. Listen, there is no sound here, save for the whisper of the wind. Mars has no oceans to crash against shores, no birds to sing at dawn, but the wind itself is a voice, carrying dust across the plains, shaping the surface in an endless, patient dance. It is a sound that is both lonely and peaceful, a reminder that even in the most desolate places, there is a rhythm, a pulse of nature. High above, the two tiny moons, Phobos and Deimos, begin to fade from view as the sky brightens. Phobos, the larger of the two, looks like a misshapen potato, its surface scarred by the impacts of countless meteorites. It rises and sets twice in a single Martian day, a swift companion to this world of slow changes. Deimos, smaller and more distant, is a faint speck, almost lost in the glow of the morning sky. Now the sun is fully up, casting long shadows that stretch across the valleys and craters. The temperature rises a few degrees, but the air remains thin and dry. This is a world of extremes, yet there is a serene beauty in its starkness. The ancient riverbeds, now filled with sand, curve like the lines on a palm, telling a fortune that only the universe can read. They are the veins of a planet that once breathed, now still and silent. Imagine the water that once rushed through these channels, carrying sediment and shaping the land. It was a force of life, a blue thread in a red tapestry. Today, only the memory remains, frozen in the rock and soil. But that memory is precious, for it holds the key to understanding not just Mars, but the potential for life beyond Earth. As the morning progresses, the dunes begin to warm, and the air grows slightly less bitter. The sky is now a pale apricot, the stars long gone. The landscape is bathed in a soft, even light, revealing every detail of the rugged terrain. In the distance, the peaks of the Tharsis volcanoes rise, their summits capped with a frost of carbon dioxide ice that glitters like diamonds in the sun. This is Mars at dawn, a place of ancient rivers and quiet dunes, of silence and beauty. It is a world that invites contemplation, a reminder of the vastness of space and the slow, steady passage of time. As you drift into sleep, let the image of this peaceful morning settle in your mind, a gentle lullaby from a distant world. Imagine, if you will, a sphere no larger than a city, yet containing the mass of an entire sun. This is the neutron star, a cosmic contradiction, a whisper left behind after a star's grand transformation. These tiny, impossibly dense objects are among the most mysterious inhabitants of our universe, and tonight we will drift gently into their story. Deep in the quiet emptiness between galaxies, a massive star lives out its long, steady life. For millions of years, it fuses hydrogen into helium, then helium into heavier elements, layer by layer, like the rings of an ancient tree. But eventually, the star runs out of fuel. Its core, no longer supported by the outward push of fusion, begins to collapse. In a heart-stopping instant, though for the star it is far from instant, the core crushes itself into a ball of pure neutrons, smaller than a city, yet holding the weight of nearly 2 suns. The outer layers are cast off in a gentle, silent cloud of gas and dust, leaving behind this exquisite, tiny remnant. A neutron star is so dense that a single teaspoon of its matter would weigh billions of tons here on Earth. If you could stand on its surface, though you never could, for its gravity would instantly flatten you into a thin smear, you would feel gravity 1 billion times stronger than what we experience. Time itself slows down near such an object, bending and stretching like a slow, deep sigh. The star's magnetic field is trillions of times stronger than Earth's, and it spins rapidly, sometimes hundreds of times per second, like a celestial top that never tires. Some neutron stars, called pulsars, beam out radio waves from their magnetic poles. As they spin, these beams sweep across the cosmos like lighthouse beams, and we on Earth can detect them as regular, rhythmic pulses, the heartbeat of a dead star. It is an astonishing thought. A star that has ended its life still sends out a signal, a faint but steady pulse, traveling across light years of silent space to reach our instruments. These tiny spheres are laboratories of extreme physics. Inside them, matter is packed so tightly that protons and electrons merge into neutrons, and the entire star becomes a single, enormous atomic nucleus held together by gravity. The laws of physics that we know, the ones that govern our everyday lives, begin to bend and twist in these conditions. Scientists still do not fully understand what lies at the core, perhaps a sea of free quarks, or even a state of matter so strange it has no name. The neutron star keeps its secrets well, wrapped in a crust of iron and a thin atmosphere of hydrogen and helium, glowing faintly with residual heat from its violent birth. When 2 neutron stars spiral together and merge, they create a spectacular event, a kilonova that sends out gravitational waves and forges heavy elements like gold and platinum. But even in that cataclysm, there is a quiet elegance, the universe recycling its most precious materials, scattering them across the void to one day become part of new stars, new planets, and perhaps new life. The neutron star's story is one of transformation, from a brilliant sun to a humble, dense cinder, and then to a source of the very atoms that make up our world. So tonight, as you rest, remember the neutron stars, those tiny, quiet spheres spinning in the darkness, each one a memory of a star that once shone. They are not loud or flashy, they are subtle, patient, and deeply mysterious. And in their silent pulse, we hear the universe whispering its oldest lullaby. Imagine you are lying on a warm hillside somewhere far away from city lights, maybe in the southern hemisphere, where the sky feels larger and stars seem to brush the horizon. As your eyes adjust to the darkness, two faint, misty patches emerge in the heavens, like cosmic clouds caught in the stillness of night. These are the Magellanic Clouds, two galaxies tucked close to home, gentle neighbors in the vast ocean of space. They have been known to humanity for thousands of years, yet they were named after the explorer Ferdinand Magellan, whose crew wrote about them in the early 1500s during their voyage around the world. But long before that, the ancestors of the southern lands, the indigenous peoples of Australia, South America, and Africa, saw these clouds as embers of ancient campfires or as soft patches of light that guided their journeys. The larger Magellanic Cloud floats about 160,000 light-years away, and its smaller companion, the small Magellanic Cloud, lies a little farther, at roughly 200,000 light-years. In the scale of the cosmos, these are our intimate neighbors, like friendly homes across the street from our own Milky Way galaxy. They are irregular galaxies, not grand spirals or great ellipses, but free-formed swathes of stars and glowing gas that drift in a celestial dance. The larger cloud spans about 14,000 light-years across, 1/10 the size of the Milky Way, but it contains regions of vibrant star formation, including the famous Tarantula Nebula, a nursery of newborn stars so brilliant that if it were as close as the Orion Nebula, it would cast shadows on Earth. The small Magellanic Cloud is more delicate, a wispy collection of stars that seems to stretch into a faint bar. Together, they are bound to our galaxy by gravity, circling the Milky Way in a slow, gentle orbit that takes hundreds of millions of years to complete. They are like two drifting lanterns, trailing streams of gas behind them, a ribbon of material known as the Magellanic Bridge, which connects the two clouds and even extends a long tidal tail called the Magellanic Stream. This gas is slowly being pulled into our own galaxy, feeding future generations of stars. How peaceful it is to think that even galaxies share their substance over time. These clouds are not just beautiful, they are windows into the life cycle of stars. Because they are so close, astronomers can study individual stars in detail, from the youngest, still cocooned in dust, to ancient red giants that have burned for billions of years. In 1987, a supernova, an exploding star, blazed in the large Magellanic Cloud, the nearest supernova seen in centuries. It was a gentle reminder that even in these calm regions, the universe is alive. When you look up at the Magellanic Clouds, you are seeing light that began its journey when early humans were still spreading across the planet. The light from the larger cloud has traveled for 160,000 years before touching your eyes. In that time, the stars within it have been born, lived, and many have already died. The image you see is a long-ago photograph of a galaxy in transition. Some nights, the clouds appear as dim companions to the brilliant Milky Way band. They are best seen in the southern hemisphere's autumn and winter months, especially from places like Chile, New Zealand, or South Africa. But even from tropical latitudes north of the equator, a careful observer can glimpse them low on the horizon. They are among the few galaxies visible without a telescope, marking them as ancient beacons for stargazers throughout history. As you drift into sleep, think of the Magellanic Clouds as two gentle eyes watching over the southern sky, silent, unhurried, and timeless. They remind us that we are part of a larger community of galaxies, each one a collection of suns and clouds, each one with its own story. And in the quiet of the night, their faint glow is a lullaby from the cosmos. Far beyond the planets, far beyond the icy rings of Saturn and the blue glow of Neptune, there lies a place so quiet and so cold that time itself seems to move at a slower pace. This is the Oort cloud, a vast spherical shell of icy debris that surrounds our solar system like a soft, ancient halo. It is not a place we can see with our eyes, not even with the most powerful telescopes. It is a realm of whispers, where tiny worlds of ice and dust drift in an endless, patient darkness. From this distant, peaceful cradle, comets are born. They are not the fiery, streaking messengers of doom that old stories sometimes imagine. No, they are slow wanderers, made of the most basic materials, frozen water, ammonia, methane, and a fine, dark dust. These are the leftovers from the birth of our solar system over 4.5 billion years ago. They have been waiting ever since, in the deep cold, undisturbed. A comet in the Oort cloud is like a gentle sleeper. It may take millions of years to complete a single, slow orbit around the Sun, if it ever comes close at all. Most of them never do. They remain in their distant, circular orbits, barely moving, as if held in a quiet embrace by the gravity of the Sun, even from so far away. The temperature there is near absolute zero. Nothing changes. It is a place of perfect stillness. But sometimes something disturbs this peace. A passing star, a gentle gravitational nudge from the Milky Way itself, or even the slow drift of the solar system through the galaxy can send a few of these icy wanderers on a new path. A very long, very slow fall toward the inner solar system. For millions of years, the comet drifts, gaining speed gradually, almost imperceptibly. It is not a dramatic plunge. It is a slow, deliberate journey, like a leaf floating down a wide, calm river. As it moves closer, the Sun's warmth begins to reach it. But this warmth is not harsh. It is gentle like the first light of dawn. The comet's surface, which has been frozen for eons, begins to warm. The ice turns directly into gas, a process called sublimation, and it carries the fine dust with it. This creates a soft, glowing envelope around the comet's nucleus called the coma. It is not a violent explosion. It is a slow, steady release, like a deep, peaceful sigh. And then, if the comet comes even closer, the Sun's energy pushes some of this gas and dust away, forming the comet's tail. But the tail is not a single fiery streak. It is two, one of gas, glowing blue, and one of dust, glowing white-yellow. They stream away from the Sun, always pointing outward, like a delicate wind sock. The comet's tail is not a sign of destruction. It is a sign of transformation. The comet is sharing its ancient, icy material with the inner solar system, a slow gift of the building blocks of life. Eventually, the comet reaches its closest point to the Sun, swings around, and begins its long, slow journey back to the Oort cloud. For some comets, this is a one-way trip. They are scattered into new orbits, or they break apart, or they crash into a planet. But for many, the return home is just as peaceful as the journey inward. The tail fades. The coma shrinks. The comet becomes a frozen, dark rock again, drifting back into the deep, quiet darkness. And so the cycle continues. A comet's life is measured in millions of years. Its wanderings are slow, its transformations are gentle, and its story is one of patience and quiet beauty. When we see a comet in our night sky, we are witnessing a traveler from the edge of the solar system, a messenger from that cold, calm place where time moves slowly. It reminds us that the universe is not always about speed and violence. Sometimes it is about the slow, steady drift of ice and dust, moving through the dark, peaceful sea of space. Imagine a world wrapped in a blanket, pale yellow and white, forever hiding its face from the curious eyes of the universe. This is Venus, our sister planet, almost identical in size to Earth, yet so different in spirit. Its clouds are not soft like the ones that drift over a sleeping forest. They are thick, heavy, and made of sulfuric acid, swirling in endless patterns around a globe that turns ever so slowly. A single day on Venus lasts longer than its entire year. Beneath this shroud, there lies a landscape of hidden valleys, ancient volcanoes, and vast plains that have never felt the touch of sunlight. It is a world of secrets, waiting to be told in the quietest of voices. As you drift into the story of this veiled planet, picture the clouds themselves. They are not a simple mist, but a layered fortress, 3 distinct decks that stretch for tens of kilometers above the surface. The uppermost layer is where the sunlight first meets Venus, scattering into a soft glow that bathes the cloud tops in a gentle, pearlescent light. Below that, the clouds grow denser, and the light fades into a perpetual twilight. And still deeper, near the surface, the air becomes thick and heavy, pressing down with a pressure that would crush any visitor. Yet within this crushing weight, there are valleys carved by ancient forces, valleys that have never known the touch of rain or wind as we know them. One of the most intriguing features hidden beneath the clouds is a vast rift valley called the Diana Chasma. It stretches for hundreds of kilometers, a deep scar in the planet's crust, flanked by cliffs that rise up like the walls of a forgotten cathedral. If you could stand at its edge, though no human ever could, you would see not blue sky but a murky orange haze, the result of sunlight filtering through the thick atmosphere. The valley floor would be dark, covered in volcanic rock that has been shaped by slow, creeping lava flows over millions of years. There is no water here, no rivers or lakes, but the landscape tells a story of immense geological activity, of a world that is still alive beneath its silent exterior. Nearby, the highlands of Ishtar Terra rise above the surrounding plains, crowned by the Maxwell Montes, the tallest mountain range on Venus. These peaks are not jagged like the Himalayas. They are rounded and smooth, worn down by the planet's extreme heat and pressure. In the shadows of these mountains, hidden valleys cradle ancient lava channels that once carried molten rock across the surface. The valleys are wide and gentle, their slopes coated in a fine dust of minerals that glimmers faintly in the dim light. It is a landscape of stillness, where nothing moves except the slow drift of the atmosphere above. Another hidden gem is the Lakshmi Planum, a high plateau surrounded by mountain belts. This is a place of contrasts, where flat valleys meet towering ridges. The valleys here are not deep canyons, but broad, shallow depressions filled with volcanic deposits that have smoothed out the terrain over eons. The silence is absolute, broken only by the low rumble of distant volcanic vents, a sound that travels through the dense air like a whisper from the planet's heart. What makes these valleys so fascinating is that they are completely hidden from our direct view. We know them only through radar mapping from spacecraft like Magellan, which pierce the clouds with careful pulses of radio waves. Each scan revealed a new secret, a winding valley here, a collapsed crater there. The images show a world that is both alien and familiar, with features that remind us of Earth's own valleys, yet formed under conditions so harsh that life, as we know it, could never survive. The valleys of Venus are a testament to the planet's violent past and its enduring mystery. As you let your mind wander through these hidden valleys, imagine the slow rotation of the planet, the sun rising in the west and setting in the east, a strange dance of light and shadow that plays across the cloud tops. Below, the valleys remain in perpetual twilight, their contours unchanged for millennia. They are silent witnesses to the planet's long, slow history, a history written in rock and lava and the relentless pressure of a crushing atmosphere. And so, as you drift closer to sleep, think of Venus not as a hostile world, but as a quiet guardian of secrets, wrapped in its shroud of cloud, with valleys that have never been touched by a human hand. They wait there, hidden and peaceful, beneath the swirling yellow sky, a reminder that even in the most extreme places, there is a certain kind of beauty, a beauty that asks only to be imagined, and then to be let go as you sink into the soft embrace of rest. Close your eyes and imagine you are drifting through the silent, endless dark of space. There is no sound here, no wind, no motion you can feel, yet everything is moving. The Milky Way, our vast galactic home, is turning, slowly, gracefully, like a great cosmic carousel set in motion billions of years ago. This is the story of its gentle rotation, and how it shapes the stars, the planets, and the quiet rhythm of our corner of the universe. Picture the galaxy as a colossal disk, a swirling spiral of hundreds of billions of stars, all bound together by gravity. It spans about 100,000 light-years from one edge to the other. At its center lies a dense, glowing core, a brilliant hub of ancient stars, and perhaps a supermassive black hole, quiet and patient. And around this core, the entire disk turns, one full rotation taking roughly 230 million years. That is a single galactic year, a span so vast that all of human history is but a fleeting moment within it. Our Sun, a modest yellow star, orbits the galactic center at about 515,000 miles per hour. Even at that staggering speed, it takes us 230 million years to complete one circuit. The last time the Sun was in its current position, dinosaurs had only just begun to roam the Earth. The time before that, the first trees were spreading across the land. And the time before that, the oceans teemed with ancient life, yet nothing had crawled onto the shore. Each galactic year, The Earth and all its inhabitants travel a long, slow path around the Milky Way's heart, as if riding a gentle, silent wave through the stars. But the galaxy does not spin like a solid wheel. Its rotation is differential, meaning the inner parts move faster than the outer parts. Stars closer to the center complete their orbit in just a few tens of millions of years, while those on the outskirts take much longer, sometimes twice as long or more. This creates a beautiful, winding pattern of spiral arms, like the swirl of cream in a cup of coffee, but stretched over unimaginable distances. These arms are not fixed structures. They are waves of density, regions where stars and gas gather as the galaxy turns, giving birth to new suns and planets in a slow, ongoing dance. As the Milky Way rotates, it also interacts with its surroundings. It pulls in small satellite galaxies like the Magellanic Clouds and occasionally brushes past larger neighbors. These gentle encounters send ripples through the disk, stirring up clouds of gas and dust and triggering waves of star formation. Yet from our perspective, all of this happens with a calm, silent majesty. There is no clash or crash, only a slow, stately ballet of gravity and light. Think of the stars as tiny ships on an immense, dark ocean. They sail together, yet each follows its own path. Some drift outward, some swing inward, but all are carried by the same slow turning of the galaxy. And we, on our little blue planet, are passengers on one of those ships, drifting through the spiral arms, through regions of dense star clouds, and across vast empty spaces, all while the galaxy itself turns. The next time you look up at the night sky, remember that you are not just looking at a static canopy of lights. You are seeing the stars of our galactic neighborhood, all moving together in a slow, silent rotation. The Milky Way is turning, and we are turning with it, carried through the cosmos on a journey that has no end, only endless, peaceful motion. So rest now, knowing that the galaxy is turning above you, a gentle, ancient lullaby of gravity and light, rocking you to sleep in the quiet night. Close your eyes for a moment and let your mind drift upwards, out of this room, past the clouds, and into the deep, quiet blackness of space. Every star you see is a sun, and many of these suns have their own families of planets. We call them exoplanets, but planets can have their own companions too, moons, silent worlds orbiting distant planets in an eternal, gentle dance. We call them exomoons. Finding them is a profound challenge. Exoplanets are tiny and dim compared to their stars. Exomoons are even smaller. We detect exoplanets by watching for the tiny dip in a star's brightness as the planet passes in front of it. An exomoon would cause a second, even smaller dip or a tiny wobble in the planet's path. It is like searching for a single grain of sand on a vast beach by the light of a distant candle. Despite this, we have heard whispers. In 2018, astronomers found strong evidence of a moon orbiting the planet Kepler 1625b. This was no ordinary moon. Kepler 1625b I appears to be as large as the planet Neptune, a gaseous world with its own deep atmosphere and swirling storms, orbiting a planet far larger than Jupiter. Imagine that, a world the size of Neptune, but it is a moon, a silent, giant companion. More recently, another candidate was found, Kepler 1708b. These are the first faint signals we have ever received from these faraway companions. The data is beautiful, but the universe keeps its secrets close. Why do we search so hard? Because of what these moons might hold. In our own solar system, moons like Europa and Enceladus are cold and icy on the surface, but beneath the ice, vast liquid oceans are kept warm by the gravitational pull of their parent planets. This is tidal heating. It creates a gentle warmth that can last for billions of years. Now imagine a large, rocky exomoon orbiting a giant planet. The constant pull of the planet's gravity stretches and squeezes the moon's core, generating heat. This heat could keep a subsurface ocean liquid. It could power volcanoes. It could create a stable, protected environment for life to begin, hidden from the harsh radiation of space. We call this the habitable edge, the perfect distance where a moon could sustain liquid water. It is a fragile, beautiful balance. These moons would be truly silent worlds. No radio signals, no city lights, just the slow, deep thunder of an ocean under an ice sheet or the gentle fall of snow on a frozen plain. Standing there, your entire sky would be filled by the planet it orbits, its bands of clouds, its great storms, perhaps even rings, a constant, majestic presence. The planet would go through phases, casting a soft, reflected glow upon the landscape. The silence would be profound. Our own moon is a rarity. It stabilizes our planet's tilt and gives us our tides. Out there, exomoons could play just as important a role. Some might be barren, some might be water worlds, some might be volcanic. The possibilities are endless. We are only at the beginning of this journey. The first confirmed exomoon will be a milestone. It will prove that moons, not just planets, are common in the galaxy. It will show us that the universe is filled with silent worlds, waiting to be discovered. As you drift off to sleep tonight, think of them. The exomoons. They are out there right now, tracing their timeless orbits around stars you can see from your window. They are waiting, silent, dark, full of potential. There might be oceans under the ice, or volcanoes on the surface, or simply the quiet beauty of a barren rock, bathed in the reflected light of its giant parent world. Whatever they are, they exist. Rest now knowing that the universe is vast, beautiful, and filled with quiet mysteries. Good night. Close your eyes if you like. Imagine a place far, far away, a place so vast and so quiet that it seems to exist outside of time itself. This is the Eagle Nebula, a stellar nursery nestled in the constellation Serpens, some 7,000 light-years from our little world. And within this nebula, there stands a structure of such haunting beauty that astronomers have given it a name that echoes through the ages: the Pillars of Creation. These are not pillars of stone or marble, as you might find in an ancient temple. No, these are towering columns of gas and dust, cold and dark, yet alive with the promise of new stars. They rise from the nebula's floor like the fingers of a giant hand, reaching out into the cosmic void. Their colors are soft, ethereal, a palette of deep blues, purples, and gentle oranges, painted by the light of nearby stars. As you drift through this scene in your mind's eye, you might notice the subtle glow that surrounds the pillars. That glow comes from a cluster of young, hot stars that were born just a few million years ago. Their fierce ultraviolet light carves into the pillars, slowly eroding them, shaping them, and causing the gas to glow like a faint, celestial ember. But do not be alarmed. This process is slow, unhurried. It has been going on for millions of years and will continue for millions more, a gentle dance of creation and destruction. The pillars themselves are immense. The largest is over 4 light-years tall, which means that if you could travel at the speed of light, it would take you 4 years to fly from its base to its tip. Imagine that, 4 years of silent flight along a column of stardust, and within these columns, something miraculous is happening. Gravity, the quiet sculptor of the universe, is pulling the gas and dust together into dense clumps. These are the embryos of new stars. Young suns, still hidden in their dusty cocoons, waiting to be born. Occasionally, you might see small, bright knots of light at the tips of the pillars. Those are jets of material shooting out from the newly forming stars, a sign that a stellar infant is about to emerge. But here, in this quiet cradle, there is no rush. The process takes its own sweet time, measured in eons, not hours. The pillars stand as guardians, holding the raw material of countless future worlds. In 1995, the Hubble Space Telescope gave us a stunning portrait of these pillars, a picture that has become one of the most beloved images in all of astronomy. Since then, newer telescopes have peered deeper into the pillars, revealing even more detail. They have found that the very tips of some pillars are being blasted away by the radiation, but from that destruction, new stars are freed, like butterflies emerging from a chrysalis. Let your thoughts drift now. Imagine floating slowly among these magnificent structures. The silence is profound, broken only by the faint hum of your own imagination. The stars above shine with a steady, unwavering light. The nebula's mist swirls in subtle currents, stirred by gentle stellar winds. There is no sound, no fear, only peace. This is a place of beginnings, where the universe quietly goes about its work of making stars. And as you rest in this cosmic cradle, remember that the atoms in your own body were once part of a nebula like this. We are all made of stardust, and in a very real sense, this is our home. So let the image of the pillars of creation soothe you, fill you with a sense of wonder and calm. Breathe slowly, and know that you are part of something vast and beautiful, forever unfolding. Imagine a world where the sun rises in the west and sets in the east, where a single day lasts just over 17 hours, yet a single season stretches for more than 20 years. This is the world of Uranus, a pale blue planet that seems to defy all the rules of our solar system. Unlike the other planets that spin upright like spinning tops, Uranus rolls along its orbit on its side, as if it were a cosmic marble that has been tilted almost completely over. Uranus is the seventh planet from our Sun, and it is a giant world, about 4 times wider than Earth. But what makes it truly unique is its axial tilt. Most planets spin with their axes roughly perpendicular to the plane of their orbits. Earth's axis is tilted by about 23 degrees, giving us our seasons, but Uranus is tilted by a staggering 98 degrees. That means its axis of rotation lies almost exactly in the plane of its orbit around the Sun. Instead of spinning upright, Uranus appears to be rolling on its side, like a giant celestial ball. Scientists believe that this unusual orientation is the result of a massive collision early in the solar system's history. Billions of years ago, a protoplanet the size of Earth may have slammed into Uranus, knocking it over and sending it into a slow, rolling spin. The impact was so powerful that it also may have created its rings and some of its moons. The rings of Uranus are faint and narrow, made of dark particles, and they orbit the planet's equator, which now points almost directly at the Sun at certain times of the year. Because of this tilt, Uranus experiences extreme seasons. Each pole gets about 42 years of continuous sunlight, followed by 42 years of darkness. When one hemisphere faces the Sun, it is bathed in constant daylight for decades, while the other hemisphere is plunged into a long, cold night. As the planet rolls along its orbit, the Sun appears to move in a strange, looping path across the sky, rising and setting in ways we can barely imagine. Beneath its calm, featureless blue-green atmosphere, Uranus hides a dynamic interior. The atmosphere is mostly hydrogen and helium, with a small amount of methane, which gives it that soft cyan color. Methane absorbs red light and reflects blue, so the planet appears as a tranquil, pale orb. But deeper down, the pressure and temperature rise dramatically. Scientists think Uranus may have a layer of superionic water, a bizarre form of water that is both solid and liquid at the same time, conducting electricity like a metal. This strange ocean might generate the planet's unusual magnetic field, which is also tilted and offset from its center. Uranus has at least 27 known moons, each named after characters from the works of William Shakespeare and Alexander Pope. The largest moon, Titania, is covered in canyons and craters, while Miranda, the smallest of the major moons, has a chaotic landscape of cliffs, valleys, and terraces that look as if they were pieced together from different worlds. These moons orbit around Uranus's equator, so they too experience the same extreme seasons, their icy surfaces alternately baked by decades of sunlight and chilled by decades of darkness. From Earth, Uranus is just barely visible to the naked eye under dark skies, appearing as a faint, steady star. It was first discovered in 1781 by the astronomer William Herschel, who initially thought it was a comet. Only later did he realize it was a planet, expanding the known boundaries of our solar system for the first time in history. Since then, only one spacecraft, Voyager 2, has visited Uranus, flying past it in 1986 and sending back the first close-up images. Those images showed a bland, featureless world, but later observations from telescopes have revealed that Uranus does have clouds, storms, and even seasonal changes, though they are subtle and slow. As we drift through the quiet depths of space, Uranus continues its slow, rolling journey around the Sun, taking 84 Earth years to complete one orbit. It is a world of gentle extremes, where the Sun never sets for half a century and then never rises for another half. It is a reminder that the universe is full of surprises, that even the most familiar things can be turned upside down. And as you close your eyes, you can imagine yourself floating near this tilted planet, watching its pale blue glow against the velvet darkness, feeling the peace of a world that rolls through space in its own quiet, unhurried way. Imagine, if you will, a vast, silent sea of space, stretching farther than any eye can see, farther than any ship could ever sail. Stars flicker like distant candles, galaxies drift like lazy islands of light, and everything moves with a slow, graceful dance. But there is something else here, something you cannot see, something that holds the whole cosmic ballet together. This is the story of dark matter's gentle pull, the invisible framework of the cosmos. Long ago, astronomers looked up at the night sky and noticed something strange. They watched the way stars spun around the center of their galaxies, expecting the outer stars to move more slowly, like the outer lanes of a merry-go-round. But instead, they found that stars near the edge were racing along just as fast as those near the center. It was as if an unseen hand was reaching out, gently tugging at every star, keeping them all in their paths. This invisible hand, they came to realize, was the pull of dark matter. Dark matter is not like the matter we know. It doesn't shine, it doesn't glow, it doesn't reflect light. It passes through everything like a ghost through a wall, yet it has mass, and where there is mass, there is gravity, a gentle, persistent pull that shapes the universe. Think of it as the hidden skeleton of the cosmos, a delicate web of threads stretching across the emptiness, holding galaxies in their places, preventing them from flying apart. If you could see dark matter, the night sky would look very different. Around every galaxy, you would see a soft, glowing halo of this invisible stuff, like a luminous fog cradling the stars. These halos are enormous, reaching far beyond the visible edges of the galaxies. They are the reason galaxies can spin so fast without tearing themselves apart. The gentle pull of dark matter is what keeps the stars singing together in harmony. And it doesn't stop there. On the largest scales of all, dark matter weaves a vast cosmic web. Filaments of this mysterious substance stretch across billions of light years, connecting clusters of galaxies like threads in a spider's web. Galaxies gather along these filaments, drawn together by the quiet, persistent gravity of dark matter. Between the filaments lie enormous voids, empty, silent regions where almost nothing exists. It is a structure so immense and so delicate that it takes the breath away. If you could see it, you would feel as though you were floating inside a cathedral of stars and shadow. But dark matter is shy. For decades, scientists have tried to catch a glimpse of it, to feel its touch in laboratories deep underground. They build detectors filled with special liquids or crystals, waiting for a rare moment when a dark matter particle might bump into an ordinary atom. It is like listening for a whisper in a storm. But the search continues, patient and hopeful. Every so often, a hint appears, a flicker of something new, and the world leans in to listen. Perhaps the most beautiful thing about dark matter is its stillness. It does not burn, it does not explode, it does not rush. It simply exists, a quiet presence that has been here since the beginning of time. It guided the first galaxies as they formed from the cooling embers of the Big Bang, and it will continue to hold them long after the last stars have faded. In a universe full of violent events and brilliant fireworks, dark matter is the calm, steady hand that keeps everything together. So the next time you look up at the stars, remember the invisible framework that cradles them. Imagine the gentle pull of dark matter reaching across the void, holding the cosmos in a tender embrace. It is a reminder that not everything needs to be seen to be real, and that sometimes the most powerful forces are the quietest ones. As you drift into sleep, let your thoughts float among those dark matter halos, safe in the knowledge that the universe is held together by something soft, something steady, something that has always been there and always will be. To understand the quiet mood of Titan, you must first imagine a world that is always in twilight. The sun, when it peers through the hazy atmosphere, is a soft pearl over an orange horizon. There is no harsh glare, no sharp shadows. This moon of Saturn is wrapped in a thick, warm blanket of nitrogen and methane, a cloak that muffles every storm into a whisper. And in that quiet, something wonderful happens: rain, but not the rain you know. Here, the clouds are made of methane, and when they finally let down their burden, the drops fall in a slow, dancing procession through the golden haze. It is a rain that rarely rushes, a rain that seems to drift more than fall, as if the sky itself is trying not to disturb the stillness below. Imagine standing on a dune of dark, damp sand. The ground is cold, but not bitter, perhaps minus 180 degrees Celsius, yet the methane ocean nearby is more like a slow, oily lake than a violent sea. There are no waves to speak of, just a gentle lapping of liquid gas against a shore of water ice pebbles. The methane rain begins as a faint hiss. It is not the drumming of a thunderstorm, but the soft sound of frozen crystals and droplets meeting the ground. Some drops never reach the surface at all. They evaporate before landing, creating a ghostly mist that rises and falls in the still air. This is the cycle of Titan, a world where moisture moves like a slow breath, in and out, day after day, season after season. The quietness of this weather is not just about sound, it is about pace. On Earth, a storm might rage for an hour and then vanish. On Titan, the rain can fall for weeks, a steady, soft drizzle that barely changes the shape of the landscape. It erodes the ice mountains not with violent force, but with patient persistence, carving smooth canyons that reflect the faint light of Saturn in the sky. And when the rain stops, it does not stop suddenly. It fades like music falling away, leaving behind a world washed clean, but not changed dramatically, just gently refreshed. There is a deeper reason for this quiet. Titan's atmosphere is so thick that the energy from the sun barely stirs it. There are no strong winds near the surface, no jet streams to drive huge weather systems. The methane rain is driven by a slow, seasonal shift, a summer that might last 7 Earth years, or a winter that takes its time to settle. The clouds gather gradually, like mist forming over a pond. They release their rain in long, lazy patterns, as if the moon has all the time in the universe and is in no hurry to finish. Sometimes when the sky is clear, the biggest moon of Saturn smiles. At least, that is how it looks to the probes that have visited. The Cassini spacecraft watched entire seasons pass, seeing the dark patches of lakes grow and shrink with the methane tides. There were no hurricanes, no lightning bolts, no noise. Just a quiet cycle of wet and dry, a slow dance of weather that could lull any listener into a peaceful sleep. Imagine the perspective of a droplet of methane. It forms high in the mist, among microscopic particles of tholin, those reddish organic compounds that stain the clouds. It grows slowly, catching other droplets, until it becomes heavy enough to fall. And then it descends through miles of haze, past floating ice particles, past layers of thin nitrogen air, past the constant twilight, until it lands with the faintest kiss on a dune or a lake. That one drop will eventually evaporate and rise again, only to fall at another season, in another place, continuing the quiet cycle indefinitely. There is no hurry, there is no danger. There is only the gentle, eternal rhythm of a moon with quiet weather. Imagine yourself lying on a grassy hill on a warm summer night, far from any city lights. The sky above is a vast, velvet darkness, sprinkled with thousands of tiny, steady stars. Some are bright, some are faint, and as you gaze up, you feel a sense of infinite peace. But what if I told you that every single one of those points of light is just the beginning? And that if you could look far beyond them, deeper than your eyes can ever see, you would find a sight so gentle and so immense it would change the way you think about the universe itself. In the mid-1990s, astronomers decided to do something remarkable. They pointed the Hubble Space Telescope, a satellite floating high above Earth's atmosphere, at a tiny, almost empty patch of sky near the constellation Ursa Major. This patch was so small that if you held a grain of sand at arm's length, it would cover it completely. It seemed like a perfectly dark, boring spot, with no bright stars or galaxies visible. But the telescope stared at that one tiny dot for 10 days straight, collecting every whisper of light that came from the deepest reaches of space. What they found was nothing short of a lullaby written in starlight. Instead of darkness, the image revealed thousands upon thousands of galaxies, each one a swirling island of billions of stars. Some were spirals, like graceful pinwheels spinning slowly in the void. Others were soft, glowing ellipses, like hazy pearls floating in a dark sea. And there were irregular ones, too, with no certain shape, just gentle clouds of light drifting together. Every single galaxy was a collection of suns, perhaps with planets orbiting in the quiet, and yet they all appeared as tiny, sleepy lights in the vastness. This image became known as the Hubble Deep Field. It's like opening a window into a world of soft, distant fires. The light from those galaxies traveled for billions of years to reach Hubble's lens. Some of those lights left their home galaxies before Earth even had life, before the dinosaurs, before the first trees, before the oceans formed. And now, that ancient light has arrived, like a gentle message from the past, telling us that the universe is full of quiet wonders. As you listen to the soft hum of the stars, imagine that each galaxy in the deep field is a lantern in a vast, silent cathedral. The colors are mostly blues, whites, and soft reds, painting a picture of calmness. Some galaxies look like delicate jellyfish, their arms stretching out lazily. Others are like tiny, glowing eggs tucked away in the cosmic nursery. And if you look closely, you can see that some galaxies are interacting, gently nudging each other, merging over eons in a slow cosmic dance. It's not violent or frightening. It's more like two clouds blending in the evening sky. Why did astronomers choose such a dark patch? Because they wanted to see the faintest, most distant objects, the ones that are too dim for our eyes, but hold the secrets of the universe's childhood. The deep field shows us galaxies that existed when the universe was only a few 100 million years old, just a baby in cosmic terms. They are small and irregular, still growing, still learning how to become the majestic spirals we see today. And they are so far away that their light has stretched into the infrared, becoming a warm, invisible glow that only Hubble's sensitive instruments could capture. Now think about the number of galaxies in that one tiny spot. In the original deep field, there are about 3,000 galaxies. And remember, that patch is just a grain of sand-sized piece of the sky. If you were to cover the entire sky with such tiny patches, you would find that there are hundreds of billions of galaxies in the observable universe. Billions of soft lights, each one a home to countless stars, each star possibly with its own family of planets. The thought is so vast, yet so peaceful, like knowing that the night sky is filled with a billion sleeping eyes, watching over us in silence. The Hubble Deep Field has been followed by even deeper images, the Hubble Ultra Deep Field and the E-Extreme Deep Field, each one looking further back in time, revealing even fainter, redder galaxies. But the original remains a favorite because it was the first time we truly saw the universe's gentle grandeur. It reminds us that we are part of something enormous, yet incredibly quiet. The universe does not shout, it whispers through light that has traveled for eons. As you drift towards sleep tonight, imagine yourself floating through that field of soft lights. Each galaxy is a cradle of possibility, a place where stars are born and die in slow, silent cycles. There is no rush, no noise, only the steady, rhythmic pulse of cosmic time. The deep field is a window, not just into billions of lights, but into a state of being that is calm, eternal, and full of wonder. Let the image of those gentle, distant galaxies carry you into a deep and restful sleep. Imagine, if you will, a vast, silent garden, not of soil and seeds, but of stone and ice. Far beyond the warmth of our sun, between the orbits of Mars and Jupiter, drifts a cosmic ring of ancient fragments. This is the asteroid belt, a place many imagine as a dangerous, crowded battlefield where enormous rocks careen and crash in endless chaos. But the truth is far more peaceful, more serene. This belt is not a war zone, it is a garden. A quiet, slow-motion garden, where rocks never truly clash. Think of it like a gentle, drifting cloud of pebbles and boulders scattered across a volume of space so vast that it defies comprehension. If you stood on one of these asteroids and looked out, you would see no nearby neighbors. The nearest rock might be hundreds or even thousands of miles away. Like a single tree in a forest so spacious that you could walk for days without seeing another. The belt is mostly empty. A great, quiet emptiness, where each asteroid follows its own slow, graceful orbit around the Sun. These ancient stones are not aggressive, they are patient. They have been drifting here for over 4 billion years, ever since the solar system was young. Back then, the planets were still forming, and the material that didn't become a planet was left behind, a gentle leftover, like seeds that never quite sprouted. The asteroids are the fragments of that early time, preserved in the cold silence of space. They are time capsules, each one holding secrets of the solar system's birth. And yet there is a subtle dance here. Over immense timescales, gravitational nudges from Jupiter and Mars slowly shape these orbits. Occasionally, two asteroids may drift close, but they rarely touch. The distances are too great, the speeds too slow, and the space too vast for true collisions. When they do pass near, it is a gentle wave, a quiet hello in the dark. The belt is a place of solitude, not conflict. It is a garden where each stone grows in its own patch of cosmic soil, undisturbed by its neighbors. In this garden, there are different families of rocks. Some are dark and carbon-rich, like ancient charcoal, holding organic molecules that whisper of life's building blocks. Others are brighter, made of silicate rock and metal, glinting faintly in the distant sunlight. There are even a few that are almost pure iron and nickel, like the cores of tiny, unborn planets. Each one has its own story, its own texture, its own journey. From Earth, we see this belt as a faint, thin band of light, a ghostly ring that stretches across our night sky. Through a telescope, it appears as a soft, scattered trail of stars, but it is not a solid ring. It is a gentle haze, a reminder of the peaceful patience of the cosmos. The asteroids do not race or fight. They simply drift, slowly, silently, through the vast, quiet garden of space. And so, when you look up at the asteroid belt, do not think of danger. Think of a calm, ancient garden, a place where rocks never clash, where time moves slowly, and where the universe shows its quiet, enduring beauty. Let your mind drift among those distant stones, floating in the gentle dark, as the stars watch over them like patient gardeners. Rest now in the peace of this cosmic stillness. Out there beyond the familiar glow of the sun, past the planets and the drifting dust of our solar system, there is a star that waits in the dark. It is the closest star to us, a quiet neighbor called Proxima Centauri. If you could travel at the speed of light, you would reach it in just over 4 years. But even in our fastest ships, the journey would take tens of thousands of years. So we can only imagine it, like a gentle whisper from the deep. Proxima Centauri is not like our sun. It is a red dwarf, small and dim, a faint ember in the vast blackness. Its light is a soft, steady red-orange, like the last glow of a dying campfire. From Earth, it is invisible to the naked eye, lost among the brighter stars of the Centaurus constellation. But it is there, always there, keeping its quiet vigil. Imagine if you could stand on a world orbiting Proxima Centauri, you would see a sky different from ours. The star would hang low, large and warm, casting a gentle, ruddy light across the landscape. The days would be long, and the nights deep and dark. There might be oceans of liquid water or frozen plains of methane. We do not know yet. But we know that in 2016, astronomers discovered a planet there, a rocky world about the size of Earth, orbiting within the habitable zone. They call it Proxima b. This planet, if it has an atmosphere, might be a place where the star's calm glow touches the surface with a perpetual sunset. The star does not flare violently like some red dwarfs. It is relatively quiet, though it can send out occasional bursts of radiation. Still, it is a peaceful presence in the cosmic neighborhood. Proxima Centauri is part of a triple star system, dancing with two brighter companions, Alpha Centauri A and B, which are visible from the southern hemisphere as a single bright star. They orbit each other in a slow, graceful waltz, while Proxima circles them from a great distance, like a shy child staying at the edge of the dance floor. This system is our nearest stellar family, a reminder that even in the emptiness of space, there are connections. The light from Proxima Centauri takes 4.24 years to reach us. That means when we look at it, we are seeing it as it was over 4 years ago. It is a message from the past, a gentle echo across the void. Scientists study its faint spectrum, searching for signs of planets, of atmospheres, of life. But for now, it remains a mystery, a quiet star that holds the promise of something more. As you drift towards sleep, think of that small, steady star, so far away yet so close. It is a reminder that the universe is full of gentle lights, each one a story waiting to be told. Proxima Centauri whispers to us across the light years, a calm, constant glow in the infinite dark. And perhaps, somewhere out there, someone is looking back at our own sun, seeing it as a faint star in their sky, wondering the same things we do. So let your thoughts drift, like starlight, across the cosmos. Let the quiet red glow of Proxima Centauri be a lullaby, a soft ember in the vast night. Rest now, under the same sky that holds this gentle star, and know that you are part of a universe full of peaceful wonders. Imagine, if you will, a star, not unlike our own sun, but perhaps a little larger. For billions of years, it has lived a quiet life, peacefully converting hydrogen into helium in its core, radiating a steady, gentle warmth into the vast darkness around it. But every star, no matter how steady, eventually reaches a turning point. For some, that turning point is not an explosion of fury, but a quiet, graceful transformation. A slow shedding of outer layers, like a tree letting go of its leaves in autumn. For others, the ending is more dramatic, yet even then, what remains is not chaos, but an exquisite, slow-motion ballet of gas and dust, a supernova remnant. When a truly massive star has exhausted its nuclear fuel, its core can no longer hold back the crushing weight of its own gravity. In a matter of seconds, the core collapses and then rebounds, sending a shockwave outward. This is the supernova itself, a brilliant flash that can outshine an entire galaxy for a short time. But the story does not end there. The violence of that moment gives way to something far more serene, the supernova remnant. Over thousands of years, the ejected material spreads outward, slowing down as it sweeps up the thin gas and dust between the stars. It becomes a vast, glowing bubble, a cosmic nebula lit by the energy of the original explosion. As you drift through the quiet of space, you might come upon the Veil Nebula, part of the Cygnus Loop. Here, the remnants of a star that died perhaps 20,000 years ago now appear as delicate, wispy filaments of red and blue, glowing softly like the thinnest silk stretched across the sky. They are not angry or violent. They are the gentle aftermath, the cooling embers of a once blazing fire. The gas is so thin that if you could scoop up a cubic kilometer of it, it would weigh less than a single grain of sand. Yet it shines, energized by the shockwave that still ripples outward, heating the gas to millions of degrees, then allowing it to cool and glow in the most beautiful colors. Another famous remnant is the Crab Nebula, the remains of a supernova observed by Chinese astronomers in 1054 AD. At its heart lies a pulsar, a spinning neutron star no larger than a city, but with the mass of a sun. This tiny, dense object sends out pulses of energy that light up the surrounding cloud of debris, making it appear to pulse with a steady, calming rhythm, like a distant lighthouse in the cosmic sea. The Crab Nebula is a place of quiet power, where the remains of a star continue to shape the space around it, not with fury, but with a slow, patient influence. Over tens of thousands of years, the supernova remnant expands and fades, eventually merging with the interstellar medium, enriching it with heavy elements, carbon, oxygen, iron, the very stuff of planets and life. So when you gaze at a supernova remnant, you are looking at the star's final gift. It is a gentle scattering of seeds across the garden of space. The star is gone, but its legacy drifts on, becoming part of new stars, new worlds, and perhaps new eyes to look up and wonder. And so, as you settle into the darkness of your own quiet room, think of these vast, slow-moving clouds, glowing in colors too faint for our eyes to see without a telescope. They are the peaceful remains of a star's life, a reminder that even the most dramatic endings can give way to beauty and stillness. The universe is full of such gentle transformations, and you are part of that same cosmic story. Let your breath slow as the remnants themselves slow, spreading ever outward into the infinite night. There is no rush, no urgency, only the soft, eternal glow of what once was and what still is in the quiet spaces between the stars. Imagine a quiet corner of the universe where a clock ticks softly in the empty darkness, far, far from any star or planet. Now imagine another clock just like it, placed near the edge of a great, heavy world, a world so massive that it bends the very fabric of space around it. The two clocks were made at the same moment, set to the same rhythm, but as time passes, they begin to drift apart. This is the gentle, mysterious truth of time dilation on a cosmic scale. Time, we have come to learn, is not a steady river flowing at the same speed for everyone. It is more like a soft, stretchy fabric, and gravity, the pull of large, heavy things, can tug at that fabric, making time slow down near them. This idea, born from the mind of Albert Einstein over a century ago, is not just a theory. It has been measured, tested, and felt in the quiet ticking of clocks on Earth and in space. Picture a spacecraft drifting far from any planet in the deep, calm void. Its clock keeps a steady, peaceful pace. Now picture a second spacecraft orbiting close to a dense, ancient star, a place where gravity is immense. The clock on that second ship ticks just a little bit slower. It is not a dramatic change, not a sudden lurch, but a gentle, persistent slowing. Each second there lasts a tiny bit longer than a second in the empty void. This is time dilation in action, a subtle dance between mass and the flow of moments. On Earth, we live with this effect every day, though we barely notice it. The pull of our planet's gravity is strong enough to slow time at the surface just a little compared to a clock in orbit. Satellites in the global positioning system, circling high above, must adjust for this tiny difference. Their clocks run a few microseconds faster each day because they are farther from Earth's heavy pull. Without this correction, our maps would slowly drift and the world would lose its way. But the story becomes even more fascinating when we look out at the cosmos. Imagine a black hole, the most massive and compact object in the universe. Near its event horizon, the point of no return, gravity is so powerful that time slows to a crawl. If you could watch a clock falling toward that black hole from a safe distance, you would see its hands moving slower and slower, as if the clock were growing tired, until it seemed to freeze entirely. Yet for the clock itself, time would still pass normally. This strange, gentle paradox is the heart of cosmic time dilation. Neutron stars, the collapsed cores of dead stars, offer another stage for this quiet drama. A teaspoon of their material weighs as much as a mountain, and their gravity is fierce. A clock resting on the surface of a neutron star would tick about 30% slower than a clock far away in space. That means if you left a twin on a neutron star for a year, they would age less than a twin who stayed in a distant spaceship. It is a slow, peaceful separation of lives, written in the language of gravity. The universe, then, is full of gentle, invisible gradients. Time flows differently near every star, every planet, every moon. It is not a single, fixed current, but a vast, quiet ocean with many layers. The heaviest objects create deep pools where time moves more slowly, while the empty spaces between galaxies are like calm, fast-moving streams. And through it all, we drift, carried by the gravity of our own world, our own sun, our own galaxy, never quite aware of the subtle slowing of moments that surrounds us. So as you lie here, listening to the quiet of the night, think of the clocks of the cosmos, ticking at their own gentle paces, shaped by the unseen hands of gravity. It is a reminder that even time itself is soft, flexible, and full of wonder. And as you drift towards sleep, you might imagine your own moments slowing just a little, wrapped in the warm, gentle pull of the Earth, cradled by the same force that shapes the stars. Good night, and may your dreams be as deep and peaceful as the space between worlds. Close your eyes and imagine yourself drifting far, far away from the busy world around you. You are floating in the deepest, quietest ocean, but this ocean is made of stars. It is the night sky, and we are about to journey to a place that is both our home and a vast, gentle neighborhood, a place astronomers call the local group. This is our galactic family, a collection of galaxies held together not by walls or streets, but by the soft, patient pull of gravity. It stretches across millions of light years, and yet, in the grand scale of the universe, it is a cozy corner, a small cluster where everything moves with a slow, majestic grace. Let us begin in the center of this neighborhood with our own galaxy, the Milky Way. From a distance, it appears like a glowing river of light swirling in a delicate spiral. Our sun is just one star among hundreds of billions, tucked away in one of its quiet arms. As you float above the Milky Way, you can see its shape, a great disk with a bright, gentle bulge at the core, where old stars gather like ancient storytellers. The spiral arms stretch outward, wrapped in layers of dark dust and glowing gas. This is where stars are born, in clouds that softly glow with the light of newborn suns. But we are not alone here. Around the Milky Way, like loyal companions, orbit dozens of smaller galaxies. They are called dwarf galaxies, and they are like tiny islands of stars drifting in the same vast sea. The most famous of these is the large Magellanic Cloud, a patch of light visible from the southern hemisphere. It drifts slowly, peacefully, its stars twinkling in their own quiet dance. Now let us turn our gaze to our closest neighbor, the Andromeda Galaxy. It is the largest member of the local group, a magnificent spiral that lies about 2.5 million light-years away. From where we float, it appears as a faint, fuzzy patch in the sky, but it is enormous, far larger than the Milky Way. Andromeda is like a gentle giant moving through space. It has its own family of dwarf galaxies, and it draws them along with its soft gravitational pull. The distance between Andromeda and the Milky Way is immense, but they are gradually, inevitably drifting toward each other. Do not be alarmed. This is not a violent collision. It is a slow, graceful merger that will take billions of years. When it happens, the two galaxies will pass through each other like two clouds of fireflies, their stars barely touching. They will reshape into a new, larger galaxy, a calm blending of light. But that is far, far in the future. For now, they simply move together, a slow cosmic waltz. The Triangulum Galaxy is the third largest member of our neighborhood. It is a smaller, more delicate spiral, often overlooked but no less beautiful. It glows with a soft blue light, filled with regions where new stars are being born. It orbits the larger Andromeda, like a shy child staying close to a parent. And between these major galaxies, the local group is filled with tiny, faint dwarf galaxies. Some are barely visible, made of only a few million stars. They float like forgotten islands, each with its own quiet history. The local group is not crowded. It is spacious and calm. Most of these galaxies are separated by vast, empty distances, but they are bound together by the invisible threads of gravity moving slowly through the darkness. As you drift among them, you feel a deep sense of peace. There is no urgency here. The local group is at rest. It is not expanding rapidly like faraway clusters. It is bound together, a small family in a cosmic ocean. Beyond its borders lie other groups and clusters, all moving away from each other as the universe expands. But here, in our neighborhood, everything is quiet and close. The stars in these galaxies have lived for billions of years, and they will continue to shine for billions more. The gravity that holds them together is gentle and patient. There is no violence, only a slow, stately motion. Think about the scale of this place. Light takes thousands of years to cross the Milky Way. The Andromeda Galaxy is so far that its light, which you see tonight, left its stars when early humans were just beginning to walk the Earth. And yet, all of these galaxies are our neighbors. They are part of the same region of space. The local group is a reminder that even in the vastness of the universe, there are small, connected communities. It is a place where stars are born, live out their long lives, and eventually fade, only to give rise to new stars. It is a cycle of quiet creation. So as you rest here, imagine the local group as a calm garden, with galaxies scattered like glowing flowers in the night. The Milky Way is your home, Andromeda is the neighbor across the cosmic street, and all the little dwarf galaxies are the friendly lights in the distance. There is nothing to fear. The universe is vast, but here in our neighborhood there is stillness. The galaxies drift, the stars shine, and everything is held together by the gentlest force in nature. Let that thought carry you into a deep, peaceful sleep. You are safe, nestled in the heart of the local group, surrounded by the soft light of a billion stars. Far beyond the familiar planets of the solar system, beyond the icy ring of the Kuiper Belt, there lies a place of profound darkness and stillness. Here, in the deep cold of space, a mystery waits, a world so distant that it has never been seen, yet its presence is felt in the gentle pull of unseen gravity. This is the story of Planet 9, a silent guardian at the edge of our sun's realm. Imagine a world where the sun is no more than a bright star, a tiny pinprick of light in an endless black sea. Its year would last tens of thousands of Earth years, a slow, patient orbit around a distant fire. This is the world that astronomers suspect exists, not with the certainty of a photograph, but with the quiet confidence of mathematics and observation. It all began with the strange paths of objects in the Kuiper Belt, a region of frozen comets and dwarf planets beyond Neptune. These objects, known as extreme trans-Neptunian objects, or ETNOs, do not move in random ways. Their orbits are clustered, tilted, and elongated, as if something massive is herding them from afar. In 2014, two astronomers, Chad Trujillo and Scott Shepard, noticed this strange alignment. They published a paper suggesting that a giant planet, perhaps 10 times the mass of Earth, might be pulling on these distant worlds. 2 years later, in 2016, Konstantin Batygin and Michael Brown at Caltech took the idea further. They ran computer simulations and found that a planet with a mass 5 to 10 times that of Earth, orbiting in a highly elliptical path, could explain the mysterious orbits. This hypothetical world became known as Planet 9. Planet 9 is not a rogue planet, wandering alone through the galaxy. It is bound to our Sun, but at an average distance of perhaps 400 to 800 astronomical units. That is 400 to 800 times the distance from Earth to the Sun. To put that in perspective, Pluto is only 40 astronomical units away. Planet 9 is so far that it would take a message from Earth, traveling at the speed of light, more than 2 days to reach it. Its orbit is thought to be tilted relative to the plane of the solar system, and it takes between 10,000 and 20,000 years to complete one lap around the Sun. What would it be like to stand on the surface of Planet 9 if it has a solid surface at all? The Sun would appear as a brilliant star, but it would not warm you. The temperature would be near absolute zero, minus 272 degrees Celsius, cold enough to freeze the air from your lungs. The sky would be black, even at midday, and the only light would come from the distant stars and the faint glow of the Milky Way. There would be no sound, no wind, no movement. Only the silent drift of time. Yet for all its isolation, Planet 9 may not be alone. Some scientists think it might have moons, captured from the Kuiper Belt, tiny frozen worlds that orbit in the darkness. Others wonder if it is a super-Earth, a rocky world with a thick atmosphere of hydrogen and helium, or perhaps an ice giant like Neptune, with a deep ocean of water and ammonia beneath a frozen crust. We do not know for certain, and that is part of the mystery. The search for Planet 9 continues. Astronomers use the most powerful telescopes on Earth and in space, scanning the sky for the faintest speck of light that moves against the stars. It is a slow, patient hunt, like searching for a single grain of sand on a vast beach, but the clues are growing. In 2021, a new study of the Kuiper Belt's most distant objects added more evidence for Planet 9's existence. The orbits of these objects are not only clustered, but also tilted in a way that is very hard to explain without a massive, distant planet. But why does this matter? Why should we care about a world we may never see? Because Planet 9 is a reminder that our solar system is not a finished thing. It is a living, changing place full of secrets waiting to be discovered. Every time we find a new world, we learn more about how planets form, how gravity shapes the cosmos, and how our own home came to be. Planet 9, if it exists, could tell us about the early days of the solar system, when planets were tossed around by the giant worlds of Jupiter and Saturn, and some were sent far away into the dark. As you drift towards sleep, think of that distant world, gliding silently through the blackness, its slow dance a lullaby of gravity. It has been there for billions of years, waiting for us to find it. And one day, perhaps soon, a telescope will catch a glimmer of light, and the mystery will become real. For now, it remains a patient dream, a gentle secret in the deep, a reminder that there is always more to explore, even in the quietest corners of the night. Close your eyes and imagine a vast, silent ocean of darkness, a velvet blackness, glittering with the distant lights of a million stars. Out there in the heart of our own little corner of this ocean, there is a star, our star, the sun, but not the harsh, blinding ball of fire you might think of on a summer afternoon. No, tonight we will see it differently. We will watch it in soft focus, like a dream through a frosted window, its edges blurred, its light a gentle, breathing warmth. This is the sun's gentle breath, the solar flare, not as a monstrous explosion, but as a soft sigh, a whisper of light across the cosmic void. Imagine the surface of the sun, a place of constant flowing motion. It is a sea of plasma, of superheated gas, so hot that matter itself becomes a glowing electric river. But in our soft focus, we do not see the violent churning. We see the slow, graceful dance of magnetic fields, like invisible threads weaving through the light. And sometimes those threads become tangled, like a soft knot in a skein of silk. When they twist too tightly, they release their tension in a burst of energy. But we will not call it an explosion. Let us call it a sigh, a gentle release of built-up warmth, a long, slow exhalation of the sun itself. A solar flare in its true nature is a sudden brightening, but in our quiet story, it is more like a candle flame flickering brighter for a moment, then settling back to its steady glow. The flare sends out light across the entire spectrum, X-rays, ultraviolet, visible light, but we do not need to think of the science. Instead, picture a soft, golden wave, like honey poured from a jar, spreading outward from the sun's surface. It travels at the speed of light, yes, but it does not scream. It flows, unhurried, across the emptiness of space, a ripple in the fabric of the solar system. The planets, including our own dear Earth, sit in this gentle bath of light. They are not harmed. They are bathed in a warm, soft glow, like a sleeping child beneath a distant nightlight. Sometimes the sun's breath is even more gentle. There are coronal mass ejections, which are clouds of solar material that drift away from the sun like dandelion seeds on a summer breeze. They travel slowly, majestically, across millions of miles. They do not race, they float. And when they reach Earth, they interact with our magnetic field, creating the auroras, curtains of green and pink and purple that dance in the polar skies. These are not violent storms. They are the sun's way of painting the sky, a slow, soft watercolor that shifts and changes as you watch. In soft focus, the auroras are like the breath of a sleeping giant, rising and falling, gentle and rhythmical. Picture the sun itself, if you will, as a great glowing ember in a fireplace. It does not roar, it glows. Its surface is a tapestry of finer details, bright points called faculae, dark patches called sunspots. But in our soft focus, these are not blemishes. They are quiet pools of shadow, places where the fire is a little cooler, a little deeper. And from these pools, sometimes a flare will rise, like a plume of smoke from a candle, curling upward, thinning, and then dissipating into the vastness of space. It is a slow, languid motion, like a dancer's arm reaching upward, then falling back. We often think of the sun as a harsh, fiery master, but in truth, it is a gentle, constant friend. Its flares are not angry, they are the natural, rhythmic pulse of a living star. Think of your own heartbeat, steady and calm. The sun has its own heartbeat, a cycle of activity that rises and falls over 11 years. Sometimes it is quiet, with few flares, like a deep, peaceful sleep. Other times, it is more active, with more of those gentle breaths. But even at its most active, the sun is not a tempest. It is a great, patient furnace, slowly giving of itself, sharing its light and warmth with all the planets that orbit around it. As we drift further into this quiet contemplation, let us imagine the view from a distant spacecraft looking back at the sun. It is small, a point of light, but it is the brightest point in the sky. Around it you can see a faint, soft halo, the solar corona, a pearly glow that is only visible during a total eclipse. But here, in our soft focus, it is always visible, a gentle crown of light surrounding the sun. And from this corona, tiny streamers of plasma extend outward, like the petals of a flower or the fine threads of a spider's web. They are delicate, almost invisible, but they are there, always reaching out, always connecting the sun to the rest of the cosmos. So let the sun's gentle breath be a lullaby. Let the slow, graceful dance of solar flares be a picture of peace. The universe is vast, and our star is just one of many, but it is our star. It is the source of all life, the warmth that wakes us each morning, and the light that guides us through the day. And at night, when we close our eyes, we can still feel its presence, a soft, distant warmth, a gentle sigh, a whisper of light across the velvet darkness. Rest now as the sun breathes softly, and the stars keep watch. Let us float together, softly, into the great quiet that lies between the stars. Imagine, if you will, a place so vast that light itself takes years just to cross from one side to the other. A place where the darkness is not empty, but filled with a gentle, ancient stillness. This is interstellar space, the silent, sprawling ocean that separates every sun from its neighbors. It begins where the influence of our own star fades, beyond the orbit of Pluto, past the whispering edge of the heliosphere, and stretches out into an endless, ink-black calm. Here there is almost nothing. A handful of hydrogen atoms drift in every cubic centimeter, so few that you could count them on your fingers. A tiny, frozen grain of dust might float past once in a great while, catching a distant spark of starlight for just a moment before it vanishes again into the dark. The temperature hovers near absolute zero, a cold so profound that it is beyond any chill we can imagine. Yet it is not a hostile cold. It is a peaceful, unchanging cold, like the deepest, most restful part of a winter night. The silence here is unlike anything on Earth. There is no wind, no rain, no hum of life. Sound needs a medium to travel, and in this thin ghost of a medium, the only noise comes from within, the faint whisper of a spacecraft's instruments, or the quiet rhythm of our own breathing. But if we could listen with a patient, cosmic ear, we might hear the very faint hiss of charged particles streaming from distant stars, or the low hum of magnetic fields stretching across light years. These are not sounds we would ever call loud. They are more like a soft, eternal lullaby sung by the universe itself. Interstellar space is not a void of nothingness, it is a gentle cradle. Within this immense quiet, new stars are born. Giant clouds of gas and dust, called molecular clouds, drift for millions of years in the darkness, slowly gathering themselves, pulling inward under their own weight. And when a spark finally ignites at their core, a new sun awakens, pushing back against the calm that once held it. Then, after billions of years, that star may fade, and its remains will drift back into the same quiet, continuing the slow dance of creation and return. Through this vast, still ocean, our own tiny world sails. The sun's family of planets, comets, and asteroids all move together through a local patch of interstellar space, carried by the galaxy's gentle rotation. Occasionally, we pass through a denser wisp of gas, a cloud left behind by some ancient supernova, and the space around our sun glows faintly with a ghostly blue light, like a thin veil of memory. But most of the time, the view is simply an immense, star-speckled darkness, with the Milky Way arcing overhead like a river of silver dust. There is a profound solitude in interstellar space, a solitude that can feel like a deep breath. It reminds us that we are part of something far larger than our daily concerns. The distances are staggering. Even the nearest star, Proxima Centauri, is more than 4 light-years away, a journey that would take tens of thousands of years with our fastest rockets. And yet, those stars are still neighbors, their light crossing the gulf to reach our eyes like a gentle greeting from across a cosmic yard. If you could float here, in a quiet spaceship with a window looking out, you would see no planets, no moons, no sun, only the soft, constant glow of the galaxy, like a luminous fog. The sky would be full of stars, but they would be still, untwinkling, steady as tiny candles in a vast cathedral. The silence would wrap around you, and you might feel a sense of peace that is hard to find anywhere else. Interstellar space is a reminder that rest is natural, that emptiness can be beautiful, that between the bright, busy moments of our lives, there is a quiet that nourishes us. As you lie here, listening, you can imagine yourself adrift among these gentle, dark waters, cradled by the cosmos, lulled by the soft pulse of distant suns. There is nothing to fear here, only the endless, patient quiet, only the space between the stars. And so let your thoughts drift like a lonely photon, traveling across the void for years without meeting another. Let the cold become a blanket, the darkness a comfort. You are safe in this wide, silent ocean. You are part of its story. And as the universe continues its slow, dreaming turn, you can rest, knowing that the quiet between the stars will always be there, waiting to hold you in its tranquil embrace. Breathe in and out. The stars keep their watch. The void is soft. Sleep well. Imagine, if you will, a quiet evening in the cosmos. The stars are scattered like grains of sand across a vast, dark ocean. Among them, galaxies drift, each a slow-motion wheel of ancient light. Now picture something extraordinary. As that light travels across the universe, it sometimes passes near a massive galaxy, a giant in its own right. And when it does, something magical happens. The light bends. Not sharply, not suddenly, but gently, like a stream of water curving around a smooth stone. This is the phenomenon we call gravitational lensing. It's as if the galaxy itself becomes a soft, invisible lens, woven from gravity itself. Let's settle into this scene. Imagine a far-off quasar, a brilliant beacon millions of light years away. Its light has been traveling for eons, a steady, silent beam. Between us and that quasar, there is a massive galaxy cluster, a congregation of stars and dark matter. As the quasar's light approaches, it encounters the cluster's immense gravitational field. And gravity, you see, is not just a force that pulls, it is a curvature in the very fabric of space. Albert Einstein predicted this, and it's as true as the stars above. The light follows that curve like a car on a banked road. It doesn't crash, it simply follows the gentle slope. Now, from our vantage point, the result is breathtaking. The distant quasar no longer appears as a single point of light. Instead, it might be stretched into a luminous arc or even split into multiple images, like a shimmering mirage in a cosmic desert. Sometimes, the light forms a perfect ring around the foreground galaxy, a halo of ancient radiance called an Einstein ring. It's a quiet, graceful distortion, a reminder that the universe is not a rigid place, but a fluid, flowing tapestry. Let's slow down and feel this. Think of a dewdrop on a leaf. The drop is clear, but it bends the light of the world behind it, making things appear larger, softer, slightly shifted. A gravitational lens does the same, but on a scale that dwarfs our imagination. The lens is a galaxy, sometimes billions of years old. The light it bends has traveled from the edge of time. And yet, the result is a peaceful alignment, a gentle meeting of paths across the cosmos. Astronomers use these lenses as natural telescopes. Because the light is magnified, we can see galaxies that would otherwise be too faint, too distant. They become clearer, like turning up the brightness on a dim screen. These images reveal the early universe, galaxies in their infancy, still glowing from the birth of stars. It's a window into our own past, a soft echo of creation. But there's more. The way light bends depends on the mass of the lensing galaxy. By studying the distorted images, we can map the distribution of that mass, including the invisible dark matter that surrounds the galaxy like a ghostly halo. Dark matter doesn't shine, but it pulls on light, revealing its presence. So gravitational lensing becomes a tool for seeing the unseen, a quiet detective story written in light. I want you to imagine you are floating in a dark, silent space, watching this happen. A galaxy drifts into view, an island of stars. Behind it, a distant cluster of galaxies sends out a soft, multicolored glow. As the light from that cluster passes near the foreground galaxy, it bends around it, forming a series of delicate arcs. The arcs are blue and amber, like the colors of a twilight sky. They are faint, almost ghostly, but they are real. They are the fingerprints of gravity. And the galaxy itself, it remains serene, continuing its slow dance across the void. It doesn't know it is a lens. It doesn't know it is bending the light of 1,000 others. It simply exists, a gentle giant in the night. So next time you look up at the stars, remember, the light you see has often traveled a winding path. It has been bent, stretched, and magnified by the gravity of galaxies that lie between you and the source. The universe is not a straight line. It is a series of gentle curves, a soft, endless lens, and we are here on our little world, peering through it, quietly marveling at the view. Now drift into sleep with that image, the galaxies, the arcs of light, the silent bending of a cosmic lens. It's all still there, happening right now, as the universe continues its peaceful, timeless work. Imagine, if you will, a vast ocean of space, not made of water, but of charged particles and magnetic fields. In this cosmic sea, there are currents that flow not with the crash of waves, but with the gentleness of a lullaby. These are the plasma currents, rivers of ionized gas that drift through the void, carrying energy and matter across unimaginable distances. They are the whispers of the universe, soft and steady, yet capable of shaping the very fabric of space itself. These currents are not like the turbulent streams we know on Earth. They move with a calm and patient grace, weaving through the darkness like silk threads in a tapestry. They are born from the sun's gentle breath, the solar wind, which sends a constant flow of particles outward into the solar system. As this wind travels, it carries with it the sun's magnetic field, creating a delicate web of currents that connect planets and stars. Sometimes these currents gather and strengthen, forming what scientists call rogue waves, but not the kind that crash against ships. These are rogue waves of plasma, slow and serene, that ripple through the emptiness of space. Picture a current of plasma flowing near a distant nebula, a cloud of gas and dust where new stars are born. The current moves with the patience of a glacier, carrying particles that have traveled for centuries. It brushes against the nebula, stirring its colors into soft swirls of blue and purple. The interaction is gentle, like a mother's hand smoothing a child's hair. The plasma current does not roar or rage. It hums with a low, steady frequency, a song that only the most sensitive instruments can hear. This is the music of the cosmos, a lullaby that has played for billions of years. But even these gentle currents can surprise us. In the vastness of space, where conditions are always changing, a plasma current can suddenly intensify. It might be triggered by a solar flare or the collision of two magnetic fields, and for a moment it becomes a rogue wave. Yet even then, it does not lose its calm. It simply flows faster, brighter, like a river that quickens its pace after a storm. It carries more energy, but it does not break its serene rhythm. It is a wave that rises without crashing, a surge that moves without violence. These rogue waves in space are not dangerous to us, not like the ones in the ocean. They are gentle giants, phenomena that remind us of the quiet power that fills the universe. They can be seen in the auroras that dance at the poles of Earth, where plasma currents from the sun interact with our planet's magnetic field. The lights that appear are the visible trace of these currents, a soft glow that paints the sky in shades of green and pink. It is a peaceful display, a reminder that even the most powerful forces in space can be beautiful and calm. As you drift off to sleep, think of these plasma currents flowing gently through the cosmos. They are the unseen rivers that connect all things, from the smallest atom to the largest galaxy. They move with a quiet certainty, a timeless grace that soothes the mind. Let your thoughts follow them, winding through the stars, until you too become part of their endless, peaceful flow. Good night, and may your dreams be as vast and calm as the universe itself. Close your eyes if you like, and imagine a place so vast and empty that the very idea of emptiness begins to feel like a story. Out there, between the stars, in the quiet corridors of space, there drifts a kind of magic so small and so gentle that it almost escapes notice. This is cosmic dust, the tiniest grains that build worlds. Picture a single grain of dust, smaller than the width of a human hair, lighter than a snowflake. It floats in the dark, alone for millions of years, but it is never truly lonely. These grains are made of the stuff of life: carbon, silicon, oxygen, iron, and 100 other elements forged in the hearts of long-dead stars. Each speck is a tiny time capsule, carrying the memory of some ancient supernova, some fiery birth that scattered its ashes across the galaxy. Now imagine a cloud, a nebula they call it, a great, slow, silent river of gas and dust stretching for light years. In this cloud, the dust grains dance like motes in a beam of sunlight, but here there is no sun, only the faint glow of distant stars. The cloud is cold, colder than any place on Earth, and it drifts in a deep, dreamy slumber. Yet within this slumber something stirs. The dust grains, so small and light, begin to cling together. They touch, ever so softly, and stick. A little bit of static electricity, a little bit of chemistry, a little bit of chance. Over time, they build tiny clumps, then pebbles, then boulders. This is the quietest of symphonies, a slow waltz of particles. The clumps grow, pulling more dust and gas toward them with their own faint gravity. A baby planet is born, called a planetesimal. It is no bigger than a mountain, but it is the start of something grand. As it grows, it sweeps up more dust from the surrounding cloud, like a child gathering scattered treasures. The dust grains, once free and floating, become part of something solid, something that will one day be a world. But not all dust becomes planets. Some remains as a delicate veil, a wispy shroud around newborn stars. These dust rings, called protoplanetary disks, are the cradles of solar systems. They glimmer with a soft, reddish glow lit by the young star at the center. From this disk, worlds like ours take shape. Earth with its oceans and mountains, its forests and skies. Every atom in your body, every grain of sand on a beach, every crystal in a mountain was once a speck of cosmic dust. And still the dust drifts. It falls to Earth every day, a gentle rain of stardust from comets and asteroids. You can find it on your rooftop, in the soil, in the air you breathe. It is the most ancient of travelers, having journeyed for billions of years to reach you. When you look up at the night sky, you are seeing the light of distant suns, but the darkness between them is not empty. It is filled with this silent, patient dust, waiting to become something new. So as you drift towards sleep, think of the cosmic dust. Think of how it floats, unhurried, through the endless dark. Think of how it gathers gently to build worlds, to give birth to stars, to weave the fabric of the universe. You are made of this dust, and so is everything you love. There is a peace in that, a sense of being part of something vast and beautiful, something that has been happening for billions of years and will continue long after we are gone. Rest now and let the dust carry you into dreams. Imagine, if you will, a sky not of this world, but of a distant future, a sky where the stars themselves are growing old. This is the tale of the end of stars, the quiet fading of white dwarfs into an eternal twilight. At the heart of every star, a fierce battle rages. For billions of years, gravity pulls inward, while the fiery furnace of nuclear fusion pushes outward. It is a perfect balance, a cosmic dance that gives a star its life and light. But nothing lasts forever, not even the stars. When the fuel for fusion begins to run low, the star's fate is sealed. For stars like our own sun, the end is not an explosion, but a gentle, gradual transformation. First, the star swells into a red giant, a bloated, ruddy sphere that expands far beyond its former boundaries. It sheds its outer layers into space, creating a beautiful, glowing shell of gas and dust known as a planetary nebula. This nebula is a farewell veil, a final exhalation of the star's life, and at its center, left behind, is the core of the former star. A tiny, incredibly dense ball of carbon and oxygen, no larger than our Earth, but with the mass of a sun. This is a white dwarf. A white dwarf is a star that has run out of fuel. There is no more fusion. The only thing that keeps it from collapsing under its own gravity is a strange quantum effect called electron degeneracy pressure. It is a leftover ember, a cooling cinder. When it is born, a white dwarf is fiercely hot, glowing with a brilliant white light, a temperature of hundreds of thousands of degrees, but it has no source of energy to renew that heat. It simply radiates. It leaks its warmth into the cold, dark space around it, slowly, inexorably, over billions upon billions of years. And so begins the longest, quietest phase of a star's life, the long cooling. There are no more dramatic events, no more explosions, no more flares. The white dwarf simply sits, a silent crystal of starlight slowly losing its glow. At first, it shines with a brilliant white, then a pale yellow, then a deep orange, and finally a dim, ruddy red. It becomes a brown dwarf, but even that is not the end. The cooling continues until the dwarf's light is so faint that it is indistinguishable from the darkness of space itself. It becomes a black dwarf, a cold, dead lump of matter, a ghost of a star, forever drifting through the cosmos. We do not know if any black dwarfs exist yet. The universe is too young. The oldest white dwarfs are still only a few billion years old, still glowing with a faint, dying light. But we can see them out there, these ancient stellar relics, their light telling us the story of their long, slow passage into twilight. They are the quietest, most patient objects in the sky. They teach us that even the brightest stars must one day fade, and that the end of a star is not a violent spectacle, but a gentle, dignified retreat into the eternal night. As a white dwarf cools, it also crystallizes. Its interior, once a roiling sea of plasma, solidifies into a giant diamond-like structure, a lattice of carbon and oxygen atoms arranged in perfect order. It is a cosmic gem, a tombstone made of diamond, silently orbiting the galaxy. The light from such a crystal star is not the fire of fusion, but the residual heat of a long-gone sun, a memory of light. And so, when you look up at the night sky, remember that every star you see is on a journey. Some are blazing giants, some are youthful sparks, and some are already on the slow path to twilight. The white dwarfs are the quiet ones, the patient ones, the ones that have accepted their fate. They are the librarians of the galaxy, holding the memory of their past lives in their crystalline hearts. They will outlast all the other stars, shining faintly for trillions of years, until the last of their warmth is gone, and they become a part of the final, eternal darkness. That is the end of stars, not with a bang, but with a whisper, a fading into the twilight of the cosmos. Imagine, if you will, a place where silence is not an absence but a presence, a place where the universe speaks in whispers of heat, not light. This is the realm of the James Webb Space Telescope, a silent observer adrift in the cold, dark expanse beyond our world. Webb does not see as we see. Our eyes are tuned to the bright, noisy spectrum of visible light, but Webb listens to the infrared whispers of the cosmos. Infrared light is the gentle warmth of a distant star, the fading glow of a newborn galaxy, the soft breath of a planet forming in a cocoon of dust. It is a language of temperatures, not colors. And to Webb, this silent language tells the oldest story of all. When you look up at the night sky, you see stars. But Webb looks through the veils of cosmic dust that hide the nurseries where stars are born. These dusty clouds are not empty. They are thick, warm, and full of promise. In infrared silence, Webb sees the faint heat of a protostar, a baby star still wrapped in its dusty blanket, slowly waking to life. It sees the gentle swirl of a planetary disk, where worlds will one day rise from the quiet chaos. And there is more. Webb can look back across billions of years, to a time when the universe was young and full of light. The first galaxies were bright and hot, but their light has stretched and reddened over the eons, becoming infrared whispers. Webb hears these whispers. It sees the faint, fuzzy glow of galaxies that formed just a few 100 million years after the Big Bang. They are not violent or terrifying. They are serene in their distance, like ancient memories held in the softest light. Consider the pillars of creation, that famous image of towering gas and dust. In visible light, they are dark and mysterious, but in Webb's infrared vision, they become translucent. The pillars glow from within, revealing the hidden stars that are sculpting them. The dust is no longer a wall, it is a veil, and Webb gently draws it aside. Even the planets in our own solar system appear different in infrared. Jupiter's storms become warm bands of calm and chaos. Saturn's rings, cold and silent, glow with their own faint heat. The ice giants, Uranus and Neptune, reveal their hidden weather, the slow drift of clouds in a world of perpetual twilight. But perhaps the most profound silence is the one Webb observes in the deep field. It stares at a tiny patch of sky, no larger than a grain of sand held at arm's length, and waits. It collects the faintest infrared light from thousands of galaxies, each one a city of suns, each one a chapter in the universe's story. And in that silence, Webb shows us that we are not alone in time. We are part of a vast, ancient, and ongoing creation. The telescope itself is a masterpiece of quiet engineering. It sits 1,000,000 miles from Earth, at a point where the gravity of the Sun and Earth balance. Its sun shield, the size of a tennis court, keeps it cold, so cold that its own heat does not drown out the faint signals it seeks. In that deep cold, Webb listens. It does not shout, it does not hurry, it waits, and the universe speaks. So when you close your eyes tonight, think of Webb floating in the silent dark, watching the universe in its gentle infrared glow. The stars are not just points of light, they are warm, breathing, and full of stories, and in the silence, you can almost hear them. Let that thought carry you into a deep, peaceful sleep, knowing that the cosmos is calm, and so are you. Close your eyes if you like, and let your mind drift far away, to the very center of a distant galaxy. There in the quiet darkness, something immense and ancient turns with a grace that is almost unimaginable. A supermassive black hole, spinning slowly, patiently, like a vast celestial wheel in the deep ocean of space. Let us think about what this really means. A black hole, you may know, is a place where gravity is so strong that nothing, not even light, can escape. But supermassive black holes are different from the small ones that form when a star dies. They are millions, even billions, of times heavier than our Sun, and they sit at the hearts of most galaxies, including our own Milky Way. They are the silent, steady anchors around which entire star systems revolve. Now imagine that great weight, that crushing mass, rotating, not fast like a spinning top, but slowly, majestically. The spin of a black hole is not like the spin of a planet or a star. It is the rotation of space-time itself, dragged around by the black hole's immense gravity. This gentle rotation creates a region around the black hole called the ergosphere, where space and time are twisted into a slow, smooth whirlpool. If you could float there, you would feel a subtle pull, like being carried by a current of pure stillness. The speed of this spin varies. Some supermassive black holes spin at nearly the speed of light, but many are more relaxed. They turn with a lazy, unhurried rhythm, taking perhaps hours or even days to complete a single rotation. For a black hole, that is incredibly slow. It is a reminder that in the universe, time moves at its own pace, indifferent to our hurried lives. As the black hole spins, it gently influences the material around it. Gas and dust, drawn in from the galaxy, form a thin, glowing disk that spirals slowly inward. This is the accretion disk, a soft, warm ring of light that orbits the black hole like a halo. The inner part of the disk glows brightly, but the black hole itself is a perfect circle of darkness, a silent eye in the center of the light. The spin causes the disk to warp slightly, creating ripples and waves that travel outward like echoes in a still pond. Sometimes jets of energy shoot out from the poles of the spinning black hole, but even these are not violent or alarming. They are like gentle beams of cosmic breath, streaming across the galaxy for millions of light years, carrying the quiet story of the black hole's rotation. These jets are invisible to our eyes, but they are there, a soft pulse in the fabric of the universe. Our own galaxy's supermassive black hole, called Sagittarius A, is a calm one. It spins slowly, perhaps once every few hours, and it is surrounded by a thin, dim cloud of gas. It does not devour stars or cause chaos. It simply sits, a peaceful giant at the center of the Milky Way, as the stars dance around it in their slow, eternal orbits. Scientists study these spins by measuring the size of the shadow the black hole casts against the background light. The slower the spin, the rounder the shadow. It is a beautiful, simple truth. Even the most mysterious objects in the universe can be understood through gentle observation. So as you drift towards sleep, imagine that calm, slow spin. The black hole turns, and with it, the galaxy turns. The stars, the planets, the dust, all are part of this delicate, endless dance. There is no rush, no danger. Only the quiet rhythm of cosmos, a lullaby of gravity and light. And in that rhythm, you can find peace. The supermassive black hole spins, and you are here, safe, listening to the story of the universe as it whispers through the dark. Let your thoughts slow down, like the spin of that ancient giant, and rest. Imagine, if you will, a picture so vast and so quiet that the only sound is the whisper of starlight brushing against the edge of forever. This is the realm of cosmic dust, the softest, most gentle substance in the universe. It is not the dust you find under your bed or on a forgotten shelf. No, it is something far more ancient and far more tender. It is the dust that drifts between the stars, the dust that cradles newborn suns, the dust that paints the sky with the faintest, most delicate hues of violet and rose. Every speck of this dust began its journey in the heart of a star. When a star like our sun grows old, it exhales its outer layers into space, like a deep, peaceful sigh. These layers are filled with carbon, with silicon, with oxygen, with iron, tiny grains that are no larger than a smoke particle, yet carry the memory of a star's entire life. And as these grains drift away, they cool and slow, becoming part of the immense, silent ocean of the interstellar medium. Over eons, these microscopic grains find each other, not with a crash, but with a gentle embrace. They are drawn together by the faintest touch of gravity and the static cling of their own electric charges. They stick, they gather, they form fluffy, airy clusters that astronomers call dust grains, and when enough of these grains come together, they create something truly remarkable, a cloud, but not a cloud like the ones you see floating in Earth's sky. No, this is a molecular cloud, a vast, sprawling mist that can stretch for hundreds of light years across the darkness. Inside these clouds, everything is soft. The temperature is only a few degrees above absolute zero, so cold that the atoms themselves slow down to a near standstill. The dust absorbs the light from distant stars, making the cloud appear dark and opaque, but in reality, it is the most tender cocoon imaginable. It is a place where time moves at a different pace, where a million years pass like a single, quiet breath. And within this soft, dark blanket, the dust begins to weave something new. It collects around tiny pockets of gas, forming denser and denser clumps. These clumps grow, and as they grow, they begin to warm ever so slightly. The warmth comes from the gentle squeeze of gravity, a slow, patient compression that is almost imperceptible. And then, one day, after millions of years of quiet gathering, the center of a clump becomes so dense and so warm that it begins to glow. A new star is born, surrounded by a disk of the very same dust that gave it life. The dust does not vanish. It remains, swirling around the young star, slowly clumping together into pebbles, then boulders, then planets. The leftover dust forms a soft, shimmering veil that reflects the star's light, creating a nebulous glow that we can see from Earth through our telescopes. It is the faintest, most peaceful light in the cosmos, a reminder that the universe is not just a place of violent explosions and crushing forces, but also a place of gentle creation and quiet beauty. When you close your eyes tonight, think of the cosmic dust. Think of how it floats, untroubled, through the vast emptiness, carrying within it the seeds of countless worlds. Think of how it cradles the stars, rocking them to sleep in the softest cradle imaginable. And know that every atom in your body, every breath you take, once drifted in those same calm clouds, a part of the universe's eternal, tender lullaby. So rest now, beneath the blanket of the night sky, and let the cosmic dust sing you to sleep with its silent, ancient song. Good night, sweet dreamer. Close your eyes if you like, and imagine a place so far from any sun that the very idea of day and night loses its meaning. This is the eternal night of interstellar space, a vast, silent ocean between the stars. Here the sky is not merely dark, it is an absolute, velvety black, deeper than the blackest gem you have ever seen. The only light comes from distant suns, so far away they seem like tiny, unmoving embers scattered across an endless dome. Yet even these faint pinpricks are islands of brilliance compared to the profound emptiness that stretches for light years in every direction. You might think that emptiness is cold and dead, but if you could drift here, gently, as if in a dream, you would find a quiet beauty that is both humbling and calming. The darkness is not empty, it is filled with the softest whispers of creation. Thin clouds of gas and dust, called the interstellar medium, float like phantom veils. They are so sparse that if you gathered a handful of this space, you would find only a few atoms, but across immense distances, they gather into delicate nebulae, glowing clouds that take on pastel shades of deep violet, soft blue, and pale rose. These are stellar nurseries, where new stars blink into being over millions of years. Their birth cries only a gentle pulse of radio waves that travel like slow ocean swells through the ether. Here time moves at a different pace. There are no seasons, no rushing winds, no urgent rhythms of life. The only motion is the slow, majestic drift of the galaxy itself, turning like a great celestial clock. You might float for eons, and the stars around you would hardly change their positions. The constellations you recognize from Earth would be strangers here, rearranged into unfamiliar patterns. The sun itself would be just one more faint star, indistinguishable from countless others. This is the ultimate solitude, but it is not lonely. It is a deep, peaceful rest, a stillness that invites you to let go of all hurry and simply be. Occasionally, a stray particle, a cosmic ray, might pass through you, a tiny echo of a supernova that exploded long ago in a distant part of the galaxy. It carries no danger, only a faint, friendly tap from the universe, reminding you that you are connected to everything that has ever been. And if you listen with your heart, you might hear the hum of the cosmos, the whisper of hydrogen atoms vibrating in the void, a frequency as old as time itself. It sounds like a slow, deep sigh. Some call it the music of the spheres. In this eternal night, it is a lullaby. The temperature here hovers near absolute zero, cold beyond what any human can imagine, but in your protective dream, you are wrapped in an unseen blanket of wonder. The cold is not biting or harsh. It is a pristine, pure absence, like the feeling of fresh snow at midnight. Your breath, if you had any, would not frost. It would simply become part of the vast, tranquil stillness. Above and below, stars appear in a breathtaking tapestry. They are not twinkling, for there is no atmosphere to disturb their light. Each is a steady, serene point of fire, ranging from brilliant white to warm amber. And beyond them, if you look closely, you might notice the soft glow of the Milky Way, a band of ghostly light that is the combined radiance of billions of suns, seen from within the very disk of our galaxy. It arches overhead like a silent river of dreams. There are no planets here, no moons, no familiar landmarks, just the great, wide openness of space itself. It is a place of utter peace, where the chaos of the universe calms to a slow, rhythmic dance. You can let your thoughts drift among the stars, untethered and free. This is the eternal night, not an ending, but a beginning. A quiet space for the soul to rest, to breathe, and to remember that we are all made of stardust, cradled in the gentle darkness of the cosmos. As you float deeper into this dream, the stars grow even softer, like distant candles slowly dimming. The silence becomes a soft hum, a primal sound that vibrates through every atom. You are no longer a person, but a part of this vast, serene night. And you know without words that you are safe. You are home. The eternal night holds you, and you sleep.